Born as a natural method of preserving meat before the invention of refrigeration, salami has evolved into a beloved delicacy worldwide and the centerpiece of a food industry worth tens of billions of dollars. But have you ever wondered how over 7 million tons of salami are produced each year? It all begins at closed-loop pig farms, where healthy pink pigs are raised and cared for as if they were destined to become part of a culinary masterpiece. Once they reach the ideal weight, they're transported to factories, where modern machinery meets the precise hands of skilled artisans. There, rich and flavorful salami begins to take shape, carrying the essence of time and the spirit of an ancient culinary tradition. Today, join Agriculture Insight as we step into the world of salami, where centuries-old heritage meets cutting-edge technology, and discover why salami is hailed as the king of dry-cured sausages. Everything will be revealed in this video. Salami, the dry-cured fermented sausage with a history spanning thousands of years, is considered one of Europe's oldest and most cherished culinary heritages. On par with Barolo wine and Parmigiano Reggiano cheese, salami in Italy is not just food, it's a cultural icon, with an annual production of over 300,000 tons and revenues reaching billions of euros. While German sausages are famous for their massive size and bold flavors, served piping hot at lively beer festivals, salami follows a completely different philosophy. Unlike sausages that are steamed and packaged within hours, salami takes anywhere from 30 days to over 12 months to ferment and dry slowly under tightly controlled conditions. With an ideal lean-to-fat ratio of 70-30, a coarse texture, and a secret blend of spices, salami offers a truly meaty bite, firm, chewy, intensely aromatic, and seductively tangy thanks to natural fermentation cultures. Interestingly, salami isn't just made from pork. Depending on the region, it can be crafted from beef, venison, donkey, or wild boar. In Spain, there's even a premium variety made from Iberico pork, a native black pig fed on acorns, known for its rich marbling, creamy texture, and nutty aroma, fetching prices as high as $250 to $300 per kilogram. And while the story of salami is full of allure and flavor, every masterpiece must start somewhere. So now let's return to where it all begins. Not in a factory, but on the pig farms, where quality is forged from the very first steps. Once insemination is complete, the sow enters a gestation period lasting around 114 days. Throughout this time, she receives meticulous care, bathed, groomed, and treated like a queen to ensure the birth of healthy, high-quality piglets. As farrowing approaches, the sow is moved to a specially designed birthing pen, providing a safe and comfortable environment for delivery. Each sow typically gives birth to 10 to 14 piglets per litter. After birth, the mother remains in the farrowing area to nurse and care for her piglets during the critical early weeks of life. Piglets nurse from their mother for about 3 to 4 weeks. In the first few days, the sow's milk contains colostrum, a nutrient-rich substance packed with antibodies that boosts their immune system and supports healthy development. After weaning, piglets transition to solid feed and are moved into group pens, each housing around 50 pigs. Here, they are fed commercial diets enriched with nutrients to accelerate growth. On average, each pig gains about 10 kilograms per month. Over the next 3 to 4 months, the pigs are intensively fattened. Their bodies grow so rapidly that they become top-heavy, barely able to move, spending most of their time lying down, eating, and drinking. Once they reach around 100 kilograms in weight, they're ready to leave the farm and become prime cuts of flavorful meat. Once the pigs meet the required quality standards, they are carefully moved to the holding area, where trucks are ready to transport these healthy, well-raised animals to the processing plant. And when everything is in place, the trucks roll out, marking the beginning of a whole new journey for the happy pigs to the pork processing facility. Upon arrival at the processing facility, the pigs are first brought into a designated resting area, equipped with ventilation systems, automatic misting, and continuous access to clean drinking water. This resting phase is crucial for reducing stress and allowing their muscles to relax, which in turn helps improve meat quality before processing begins. Do you think these clean pigs are happy and ready to be processed? After the pigs are bled, they move on to the de-hairing process. Here, their bodies are treated with hot water and mechanical tools to efficiently remove all the bristles, preparing them for the next stage of processing. In the cutting section, automated bandsaws split the pig carcasses vertically from neck to tail. The legs are the first parts to be removed during the initial processing stage. Using high-powered specialized saws from industry-leading brands such as Jarvis, Freund, or Best & Donovan, workers make a single, decisive cut through the joint to separate the legs quickly and efficiently. Modern facilities employ 3D scanning technology to pinpoint precise cutting lines, ensuring consistent size and weight across each half. This not only maximizes meat yield, but also streamlines the workflow for subsequent processing steps. As the carcasses are divided into loin, belly, ribs, or ham, their destinies begin to diverge. Prime cuts like ribs, tenderloin, or pork belly are packaged for fresh retail markets. Meanwhile, shoulder and butt cuts, prized for their firm texture and ideal fat ratio, are selected for a different path, the long, transformative journey into salami. The secret to crafting high-quality salami lies in the meticulous selection of raw materials. Only firm, low-sinew cuts from the pork shoulder and butt are used, ensuring excellent binding and structural stability throughout the curing process. But what truly sets salami apart from regular sausages is its precise blend with pure white back fat, which makes up about 25 to 30% of the total mixture. This fat is carefully selected not only for its purity, but also for its high melting point, allowing it to retain its shape during the drying phase. This results in salami that's not only rich and flavorful, but also maintains a firm texture and visually appealing marbled appearance after months of fermentation and drying. Once sorted, all meat and fat are rapidly frozen at temperatures between -18°C to -24°C to prevent bacterial growth and preserve natural structure. Once thawed, the meat is moved to the preparation area, where large chunks are first cut into smaller pieces using industrial slicers. For traditional salami, the meat must never be ground too finely. It's only coarsely chopped to preserve that iconic texture, where distinct chunks of meat and fat are clearly visible in every slice. The chopped meat then travels along a conveyor into an industrial screw-type grinder. This system pushes the mixture through sharp blades and large hold filters. The result? Thick, coarse strands of meat interspersed with pure white fat chunks, delivering a perfect and consistent lean-to-fat ratio, essential for authentic salami. Next comes one of the most critical steps, the secret behind the signature flavor of every premium salami: spice blending. This isn't just about seasoning, it's where each factory crafts its own distinct fingerprint that defines its salami. While every producer guards their recipe closely, a classic salami spice mix typically includes refined salt, ground black pepper, crushed garlic, sugar or dextrose, coriander seeds, and sometimes nutmeg or sweet paprika. These ingredients not only contribute to a balanced flavor profile, but also play key roles in fermentation and preservation. For most modern salami, starter cultures, usually strains of lactic acid bacteria like Lactobacillus or Pediococcus, are added at this stage. Though used in small amounts, these microbes are powerful enough to kickstart fermentation and maintain microbial control. However, in traditional salami varieties, producers often skip the added cultures in favor of slow, natural fermentation that relies on native bacteria in the environment, a method rooted in centuries-old artisanal practice. Once the mixture reaches perfect consistency in color, aroma, and texture, it's ready to move on to stuffing, where salami begins to take its iconic shape. At this stage, the seasoned meat mixture is loaded into a hydraulic or vacuum stuffer, then pushed through stainless steel nozzles into natural or synthetic casings. These casings are typically made from collagen or cleaned animal intestines, depending on the type of salami, its size, and regional style. The most critical aspect of this step is precision. The stuffing process must eliminate all air pockets, as trapped air can disrupt fermentation or cause spoilage of the final product. That's why the ends of salami and other sausages are always tightly sealed with string or specialized metal clips, a seemingly simple detail, yet one that many people still often wonder about. Next, the salami links are hung on stainless steel racks and moved into fermentation chambers, tightly controlled environments where temperature, humidity, and airflow are precisely regulated. Fermentation typically lasts between 24 to 72 hours, maintained at around 22 to 26 degrees Celsius, with humidity levels of 85 to 90%. During this period, the lactic acid bacteria introduced earlier become active, producing lactic acid that lowers the salami's pH to around 5.0 or below, a crucial safety threshold that inhibits harmful bacteria and mold growth. After fermentation, the salami is moved into drying and curing chambers. Here, conditions are kept cooler, typically between 10 to 15 degrees Celsius, with humidity levels around 70 to 80%. This phase can last anywhere from several weeks to several months, depending on the size and type of salami. During this time, moisture gradually evaporates from the salami, reducing its weight by 30 to 40%. As it dries, the flavor deepens, the texture becomes firmer, and a natural white mold begins to form on the casing, a hallmark of well-fermented, traditionally aged salami. Once the salami has reached optimal maturity, each batch undergoes a thorough quality inspection before entering the packaging stage. A properly matured salami produces a distinct hollow sound when tapped, indicating that it has dried evenly on the inside. On the outside, a natural white mold layer, evenly spread and about 1 to 2 millimeters thick, is a clear sign that the fermentation and curing processes have occurred correctly. For whole salami sausages packaged in the traditional style, or for certain premium products, the white mold layer is usually left intact, with only excess mold gently brushed off if it becomes too thick. In contrast, for pre-sliced, vacuum-packed salami sold in supermarkets, the mold-covered casing is typically removed or cleaned before slicing to ensure a uniform appearance, visual appeal, and easier preservation. From here, the salami is ready for distribution, heading to supermarkets, gourmet stores, or exported worldwide. Thanks to strict quality control and advanced technology, every salami is not just a fermented meat product. It's a culmination of precision, tradition, and global food safety standards. The United States leads the world in cheese production, making up about 25% of the global supply. At the heart of this is Wisconsin, aptly called the cheese state, where an astounding 3.5 billion pounds of cheese are produced each year. Cheese is more than just a beloved food. It's a vital part of the U.S. economy, contributing over $64 billion annually and driving growth in the dairy industry. With a rich history and an endless variety, cheese comes in hundreds of different forms, yet the process remains the same. Milk is processed, curdled, whey is separated, the cheese is pressed, salted, aged, and then packaged. Each step plays a crucial role in shaping the flavor, texture, and overall quality of the finished product. In the U.S., cheddar cheese is one of the most popular and widely produced types of cheese, accounting for nearly 30% of the country's total cheese production. In advanced production facilities, every step of the process is a crucial link, where humans and machines work in harmony to create smooth, golden blocks of cheese with a rich, perfect flavor. The journey to creating these smooth, golden cheddar blocks begins on lush green farms, where healthy cows are raised under strict conditions to produce high-quality fresh milk. Skilled farmers, supported by modern milking machines, carefully harvest every drop of pristine milk, preserving its natural flavor and freshness. After being carefully selected, the milk enters the pasteurization stage, a precise process designed to eliminate harmful bacteria while preserving its natural flavor. In large processing tanks, the milk is quickly heated to about 161.6 Fahrenheit for a few seconds, then immediately cooled down. The machinery operates with pinpoint accuracy down to the millisecond, but it is the human supervisors who ensure that no mistakes occur. To create the signature flavor of cheddar cheese, lactic bacteria are added to the milk. These beneficial bacteria help ferment the milk and thicken it into a more solid form. At the same time, a small amount of annatto, a natural colorant extracted from the seeds of the achiote tree, may be added to give cheddar its distinctive orange hue. When the enzyme rennet is introduced, the milk begins to coagulate into curds. With the help of robotic arms stirring the mixture, the curd is cut into uniform pieces using special cutting grids, allowing the whey to drain more efficiently. Unlike many other cheeses, cheddar undergoes a unique process known as cheddaring, which helps create its firm, elastic texture and characteristic bounce. After separating the whey, large blocks of curd are stacked on top of each other to allow gravity to press out excess moisture. But the process doesn't stop there. The curd is continuously flipped, folded, and pressed in cycles, tightening the protein structure. Initially soft and crumbly, the curd becomes firmer with each turn while still retaining its ideal elasticity. In industrial production, salt may be applied either before or after the curd is broken into smaller pieces, depending on the technology used by the factory. In some places, salt is sprinkled directly onto the curd strips right after the cheddaring process, then sent through a large funnel machine to break the curd into smaller pieces. This method allows the salt to evenly permeate each piece of curd during the cutting process, eliminating the need for additional mixing afterward. Alternatively, some factories opt to break the curd first, then add salt and mix it thoroughly to ensure optimal absorption. Regardless of the method, the main goal is to use the salt to control moisture, aid in fermentation, enhance the flavor, and extend the shelf life of the cheddar cheese. While the science of making cheddar cheese is essential, the aging process is truly an art. After being pressed into molds, the blocks of cheddar are placed in aging rooms where temperature and humidity are strictly controlled. Here, enzymes and bacteria continue to work, breaking down proteins and fats to develop the cheese's distinct flavor. The aging period can range from a few months to over 10 years, and it ultimately determines the flavor and texture of the cheese. Young cheddar, 3 to 6 months, has a mild, creamy taste and smooth texture. Aged cheddar, 2 to 10 years, becomes firmer, crumblier, with a rich, sharp flavor that may have a bit of spiciness and a long-lasting finish. The glistening tyrosine crystals on the surface are a sign of a perfectly aged cheddar. In modern factories, once the cheddar has fully aged, it is packaged entirely by automated systems to ensure quality and extend shelf life. Large blocks of cheese are cut into smaller portions using industrial machines, sliced or shredded based on market demand. The cheese then moves to the automated packaging line, where machines perform vacuum sealing, wrap it in plastic, or coat it with wax to prevent moisture loss and protect it from bacteria. Finally, the product is labeled, quality checked, and sent to cold storage before being distributed to the market. Alongside modernly packaged cheddar, Parmesan stands as one of the world's most beloved cheeses, particularly in the US and Europe. Officially known as Parmigiano Reggiano, Parmesan is not only famous but also crowned the king of cheeses for its rich flavor, firm texture, and impressive aging ability. Compared to cheddar or mozzarella, this cheese undergoes a more stringent production process and a much longer aging period, resulting in a distinct difference in both taste and texture. One of the standout features of Parmesan is its production in copper vats, something rare in today's cheesemaking world. Most modern factories have switched to using stainless steel vats, as they're easier to clean and maintain. However, traditional cheesemakers still swear by copper, as it better conducts heat, allowing the milk curdling process to occur more efficiently and contributing to the complex flavor development during the aging phase. This is what gives Parmesan its signature, crisp, crumbly texture. The curdling process of Parmesan is similar to that of cheddar. However, instead of using an automatic curd cutter, traditional cheesemakers rely on the spino, a long stirring stick with a fan-shaped blade, to cut the curd into uniform small grains, helping to remove the whey more efficiently. In large-scale production, the spino is often replaced by an automated stirring machine with stainless steel blades, speeding up the process and ensuring consistency across batches. Nevertheless, cutting curd with the spino results in grains that aren't perfectly uniform, contributing to the distinctive crumbly texture of Parmesan. Once the curd has fully set, it sinks to the bottom of the vat, where it's collected using linen cloth, pressed into a large block, placed into round molds, and gradually pressed to remove any remaining whey in preparation for the salt bath. A significant difference between Parmesan and cheddar lies in the salting process. While cheddar uses dry salt, which is sprinkled directly onto the curd after the cheddaring process to control moisture and flavor, Parmesan is fully immersed in a saltwater bath. This process lasts from 18 to 25 days, depending on the size of the cheese wheel. The salt bath allows Parmesan to gradually absorb the salt, develop a natural hard rind, and contribute to the signature crumbly texture that defines the cheese as it continues to age. After the salt bath, the Parmesan wheels are left to dry naturally before entering the aging phase. Another distinctive feature of Parmesan is that each cheese wheel is stamped with the words Parmigiano Reggiano, along with the factory's registration number, allowing for traceability and ensuring quality. This is rare among mass-produced cheeses, which typically just get packaged without any special identifying marks. In large-scale factories, the cheese pressing process is often automated, instead of relying on gravity and the lengthy process used in traditional methods. While this boosts production efficiency, it can affect the natural firmness of handcrafted Parmesan. Parmesan is aged for a minimum of 12 months, with many cheese wheels maturing for up to 60 months. The longer the aging, the more intense the flavor becomes, developing complex notes of butter, hazelnut, light caramel, and sometimes even a rich umami flavor. Compared to other popular cheeses, Parmesan has a much longer aging process, which helps create its signature crumbly texture and exceptional storage ability. Notably, during aging, Parmesan develops tyrosine crystals, giving it a light crunch when you bite into it, something few other cheeses can boast. Another highly consumed cheese in the US is mozzarella, renowned for its soft, stretchy texture and excellent meltability. Thanks to its smooth melting ability and mild flavor, mozzarella is the top choice for many dishes, especially pizza, pasta, sandwiches, and salads. Unlike harder cheeses like cheddar or Parmesan, mozzarella doesn't undergo a lengthy aging process. Instead, it is used fresh, preserving its high moisture content and characteristic elastic texture. One of the most important steps in creating mozzarella's signature texture is the pasta filata process. Unlike other cheeses that are pressed and aged to form a firm texture, mozzarella undergoes a special kneading and stretching process. Once mozzarella reaches the desired stretchiness, the cheese is formed into small balls, large blocks, or long strands, depending on the intended use. An important step in this process is immersing the cheese in cold water or brine to set the shape, stabilize the structure, and extend its shelf life. So, we've explored together the modern factories where cheese is produced through a meticulous process, blending advanced technology with traditional expertise to create unique flavors loved all around the world. Few would guess that crab sticks, those familiar orange-red strips on sushi trays, actually began as a response to a surplus crisis. In 1960s Japan, soaring fish catches flooded the market with low-value species like pollock and threadfin bream. To save the fishing industry, Japanese food engineers invented an artificial crab meat made from surimi, minced and refined white fish. And with just a touch of red coloring to mimic crab leg meat, the world was convinced. If Japan was the birthplace of crab sticks, then the United States became the grand stage that launched them to global fame. Every year, Americans consume over 100,000 tons of crab sticks, making them a staple in more than 60% of packaged sushi trays, seafood salads, and ready-to-eat meals from New York to California. Compared to real crab sticks cost 5 to 10 times less, making them the perfect choice for anyone craving crab without breaking the bank. Though just an imitation, the value of crab sticks is anything but fake. They're convenient, easy to store, protein-rich, and ready to eat straight from the pack. And every journey has a beginning. For crab sticks, that adventure starts in the frigid Bering Sea, where ice still clings to the surface even as spring arrives and Arctic winds howl through day and night. It is here, in these harsh waters, that pollock and threadfin bream, the two primary ingredients, are harvested amid crashing waves and freezing mist, marking the start of a remarkable transformation from deep sea to dinner plate. Unlike sardines that gather near the shore or tuna that hide in the warm depths of tropical oceans, white-fleshed fish like Alaska pollock and threadfin bream swim in massive schools in the mid-water and bottom layers, at depths beyond 300 meters where sunlight no longer reaches and human eyesight becomes useless. But humans don't stop at the limits of vision. Today, fishing is no longer a game of luck, it's a battle of technology. On deck, experts monitor sonar screens and high-frequency echo sounders. When the signals appear, thick color bands drifting across the screen like clouds beneath the ocean, the captain gives the order to drop the net. The midwater trawl, a gigantic net with an opening hundreds of meters wide and as tall as a 10-story building, is released, expanding like a colossal funnel in the heart of the ocean. In just minutes, hundreds of tons of white fish, from shimmering silver pollock to pinkish threadfin bream, cascade onto the deck like a living waterfall. Their glittering scales reflect the floodlights, turning the ship's deck into a glowing burst of life in the dark sea night. But this is not an endless harvest. Every ship carries an independent observer, specialists tasked with meticulously recording every single fish brought aboard, from total catch weight to the proportion of juveniles, male to female ratio, and even the unintended bycatch. Everything is documented and sent to the Central Fisheries Management Center. Because in the modern world, fishing isn't just an industry, it's a commitment to the ocean. A long-term contract between humans and the sea, where profit, livelihood, and conservation must walk hand in hand. Break this agreement, and the price may be the disappearance of a life source that has sustained us for centuries. The moment the net is hauled up from the depths and the first fish hit the deck, the race against time begins. On modern factory ships, fish are not left piled up waiting to be processed. Instead, they are immediately rinsed with clean seawater and transferred into chilled storage holds, filled with ice at temperatures close to 0 degrees Celsius. This thick layer of ice doesn't just prevent protein breakdown, it also inhibits bacterial growth and slows oxidation, the silent threats that can ruin an entire haul in just a few hours. This cold buffer step is crucial, preserving the fish's freshness before it enters the onboard processing line. After being chilled on board with crushed ice at temperatures near 0 degrees Celsius, the fish are quickly transported to land in insulated containers, ready to enter the processing phase at the factory. Next, the fish are poured into large stainless steel washing tanks, where the cleaning process begins under strict temperature and hygiene controls. Here, high-pressure spray systems use seawater or chilled fresh water, kept below 5 degrees Celsius, to rinse off the slime, sand, fish scales, and any remaining impurities from the surface after their long journey from the ocean. The water pressure is strong enough to remove contaminants, yet gentle enough to preserve the delicate structure of the fish flesh. This step is critical in stabilizing quality from the very beginning, preventing cross-contamination and ensuring the final surimi reaches its highest level of purity. Right after the fish are thoroughly washed, they go through essential pre-processing steps, including skin removal, cutting off the head and tail, and removing all internal organs, leaving only the pure white fillet, rich in protein and low in fat, which serves as the primary ingredient for surimi production. However, even though machines handle most of the rough processing, one critical step remains that automation cannot replace: manually removing tiny bones under a backlit inspection table. Workers use specialized gloves to carefully inspect and extract each small bone by hand. This is a vital quality control step, ensuring that the raw material entering the grinding phase is as pure as possible. Next, after the fish are filleted, the white flesh is sent directly into a high-capacity grinding system, the starting point of its transformation into a standardized industrial ingredient. Here, the grinder, the core machine of the production line, operates non-stop, processing hundreds of kilograms per hour and several tons of raw material per shift. Have you ever wondered why fresh pollock or threadfin bream has a pale pink color but turns bright white after grinding? That's because this process doesn't just shred the flesh, it also continuously washes it, removing blood, oils, and fishy odors, leaving behind only the purest protein. The result is a smooth white surimi block with no smell and no flavor, ready to become crab sticks, fish cakes, and more. Each hour, the system can process 2 tons of fish, up to 40 tons per day. That means within just a few hours, fish freshly pulled from the ocean are transformed into pristine white raw material, ready to enter the global food industry. After being ground and thoroughly washed, the smooth white surimi is transferred to a mixing tank and combined with about 2 to 3% salt. Salt not only draws water out of the muscle fibers, but also helps unlock the protein structure, making the protein chains more flexible and capable of forming strong bonds. Once mixed, the surimi is precisely portioned using an automated weighing system and packed into stainless steel trays or specialized PE bags, designed to withstand low temperatures and prevent moisture absorption. This packaging process takes place in a chilled room below 10 degrees Celsius to inhibit microbial growth and prevent heat-induced protein denaturation. Immediately afterward, the packed surimi is transferred to a deep freezer at 30 degrees Celsius for rapid freezing, which stabilizes the protein structure and secures the mechanical bonds within the fish flesh. This is a technically advanced preservation step that ensures the surimi retains its moisture, avoids protein degradation, and maintains high quality until it reaches the crab stick processing plant. And this is the moment when the crab stick factory begins its work, the stage we've all been waiting for. The mixing phase is the heart of crab stick production, where smooth white surimi blocks, extracted from pollock and threadfin bream, begin their remarkable transformation. They're fed into massive industrial mixers, where hundreds of rotating paddles churn continuously in a deeply chilled environment. Here, crushed ice and brine don't just keep the temperature low, they act as protective shields, preventing protein breakdown and preserving the firm, springy texture of the fish mass. Next, vegetable oil along with supporting ingredients like egg whites, concentrated soy protein, and natural crab flavoring are added to the mixture. These components not only provide a glossy finish and subtle richness, but also act as emulsifiers, allowing water and oil to bind smoothly, resulting in the distinctive elastic and creamy texture you experience in every crab stick. The mixture is then kneaded continuously in a low-temperature environment to prevent protein denaturation. Once it reaches the ideal consistency, soft and stretchy like mochi dough, yet resilient enough to be pulled into strands without breaking, the surimi is ready for shaping. Each mixing batch can process up to 500 kilograms of material in under 15 minutes, enough to produce tens of thousands of crab sticks in a single production shift. This is the key stage that defines the eerily crab-like texture consumers around the world have come to recognize. Once the white surimi mass has been kneaded to a perfectly smooth consistency, the factory moves on to the most crucial stage, creating the iconic orange-red streaks. This colored layer is what visually tricks the eye, making crab sticks look almost indistinguishable from real crab leg meat, with delicate red strands woven through pristine white flesh. But this isn't just a matter of adding color. A small portion of the surimi is separated, ground even finer, and blended with chili powder, red yeast rice extract, and a closely guarded flavor formula, one that's been kept secret for decades. This vibrant mixture is then shaped into fine strands that become the imitation crab fibers. To achieve the perfect balance, food engineers spent decades testing and refining formulas, measuring down to the gram, adjusting ratios, and running hundreds of trials. Eventually, the industry standardized the ideal proportion. For every 100 kilograms of white surimi, around 3 to 5 kilograms of red fiber are added. It's just enough to create lifelike marbling while keeping the white meat dominant, faithfully mimicking the natural structure of real crab legs. Without that iconic orange-red streak, a crab stick simply wouldn't be a crab stick. It's this detail that transforms a processed seafood product into a masterful illusion, one that convinces millions around the world they're tasting real crab. Once the white surimi has been fully blended with oil and seasonings, the mixture moves into the extrusion system. This process isn't simply about adding color, it's about sculpting the outer layer of crab meat using precision simulation technology. The machine presses the surimi into thin, flexible sheets, uniform and smooth like edible paper, before spraying a fine layer of the signature orange hue across the surface. This forms the imitation crab leg shell. The colored surimi sheet is then rolled tightly into long cylindrical logs, with the red layer wrapped on the outside and the white interior tucked within. As these rolls move along the conveyor belt, they are gently compressed to create a fibrous texture that mimics the natural muscle strands of real crab. Thanks to this highly efficient process, the food industry now produces over 2.5 million tons of crab sticks annually, fueling sushi trays, seafood salads, and street food favorites from Tokyo to New York. After being shaped into long rolls, the crab sticks are transferred to an automated cutting system. Razor-sharp blades operate continuously at high speed, slicing each surimi stick into uniform segments with a standard length of approximately 7 to 9 centimeters. You might think of mayonnaise as just a simple condiment in your daily sandwich or salad, but in the global food industry, this creamy sauce is considered white gold, generating a staggering $14 billion in revenue each year. In the global condiment market, the US holds the crown thanks to its massive production scale and advanced technology. Led by Hellmann's, the giant brand that commands 45% of the North American market. Every day, around 1.2 million bottles of mayonnaise are produced and shipped from Hellmann's factories, finding their way onto millions of dining tables worldwide. If Hellmann's is the king of the mainstream, familiar, easygoing, and everywhere, then Duke's is the choice for the few. With a no-sugar formula, a thick and creamy texture, and a bold southern flavor, Duke's doesn't aim to please everyone. It wins over those who value authenticity and demand precise control over every ingredient. To produce millions of jars of high-quality mayonnaise each day, it all starts with one essential ingredient: eggs. And that journey begins on the laying hen farms. There's a little-known fact. Egg quality doesn't depend solely on breed or nutrition. It also stems from the hen's comfort, living conditions, and stress levels. In modern farms, animal welfare is no longer a choice, it's a technical standard. Laying hens are raised in clean, well-ventilated housing systems, with natural lighting and fresh air circulation controlled automatically around the clock. Their diets are carefully tailored to each growth stage, rich in protein and balanced in minerals, to strengthen immunity and ensure consistent laying cycles. There's no panic clucking, no overcrowding, no unpleasant odors. Instead, a closed-loop system is maintained, where every egg is produced under optimized conditions of nutrition, environment, and health. It's the foundation behind the consistent quality of millions of jars of mayonnaise. After a period of meticulous care, the hens enter their laying phase. In modern farms, whether free-range or industrial, the health and productivity of each hen is closely monitored to ensure optimal efficiency. Nesting areas are specially designed with clean, cushioned spaces, providing a calm environment for the hens to leave behind a fresh gift each day. On average, a hen lays one egg every 26 hours, nearly one egg per day. At an industrial scale, egg collection is handled by highly efficient automated systems. As soon as the egg drops onto a soft tray beneath the nest, it is gently transferred onto a conveyor belt that runs the length of the housing rows and carries it straight to the central collection area, without any human intervention. Thanks to this system, large farms can gather between 200,000 and 500,000 eggs per day, meeting the enormous raw material demand of the mayonnaise industry. If that number feels hard to grasp, consider this. Eating through all those eggs would take over 1,300 years, assuming you had the lifespan of a legendary tortoise. Once collected, the eggs are temporarily stored under tightly controlled temperature and humidity conditions before continuing on to the next stage, processing at the factory. Mayonnaise is primarily made from egg yolks and vegetable oil. Therefore, handling the eggs properly before they enter the production line is a critical step. As soon as the eggs arrive at the facility, they undergo a strict quality control process. Advanced LED candling systems and high-resolution image sensors are used to detect any defects such as hairline cracks, thin shells, fertilized eggs, or internal impurities. At the plant, more than 60,000 eggs can be inspected every hour, fully automated, with no manual handling required. Any egg that fails to meet the standards is immediately removed from the production line. Only those that pass strict criteria for shape, size, and safety are allowed to proceed. In certain markets like the United States, egg washing is a mandatory step to remove dirt, feathers, and surface bacteria. Eggs are sprayed with warm water, combined with a mild sanitizing solution to clean the shell without compromising the structural integrity of the egg inside. However, in Europe, this process is generally avoided to preserve the egg's natural protective layer, the cuticle, which helps prevent bacterial intrusion. Instead, strict hygiene standards are enforced throughout the production and storage process to maintain cleanliness without stripping away this natural barrier. After washing, the eggs are sorted using an automated weighing system. Each egg is weighed and categorized into standard size classes, such as S, M, L, or XL. This classification ensures consistency in egg size across production batches, helping maintain stable, predictable quality in the mayonnaise manufacturing process. Next, the eggs are transferred to a specialized separator to extract the yolks, the key ingredient in mayonnaise, as they contain lecithin, a natural emulsifier that allows oil and water to blend smoothly. The machine operates based on physical separation principles such as centrifugal force, gravity, or rolling mechanisms, starting with a gentle cracking of the shell to avoid breaking the yolk. Compared to manual labor, modern separation machines are 10 to 20 times more efficient, capable of processing thousands of eggs per hour. These systems not only save time but also ensure that the extracted yolks are pure, hygienic, and ideal for high-quality mayonnaise production. The yolk is then separated from the white and shell through dedicated chambers. The system operates at speeds of up to 60,000 eggs per hour, yet the yolk breakage rate remains below 2%. After separation, the liquid yolk is passed through a low-pressure microfiltration system to remove any remaining impurities or shell fragments. It then undergoes low-temperature pasteurization, around 60 to 65 degrees Celsius, a process gentle enough to eliminate harmful bacteria without denaturing lecithin. After processing and preparation, the products are packed into specialized containers, stored under strict conditions, and transported to mayonnaise manufacturing facilities to be used as a key ingredient in the next stage of production. In addition to using liquid yolk, many factories also convert yolk into dried egg powder through spray drying or freeze drying methods. When rehydrated with water, this powder restores the emulsifying properties of fresh yolk, preserving the flavor and thickness of the mayonnaise. And now, let's dive into the mayonnaise production process, the part we've all been waiting for. This is where science, precision, and flavor come together to create one of the world's most iconic sauces. First, the pasteurized liquid egg yolk is automatically pumped from intermediate storage tanks into large stainless steel mixing vessels, each with a capacity ranging from several hundred to several thousand liters. This closed-loop pumping system prevents external contamination and preserves the yolk's integrity, ensuring maximum purity and optimal emulsifying properties. In some factories, fresh yolk is replaced with dried egg powder, a remarkable ingredient that can be revived with just pure water. Before use, the powder is finely sifted under high pressure to remove clumps and impurities, then dissolved at precise ratios in a specialized mixing tank. After the egg yolk is pumped into the mixing tank, other ingredients such as vinegar or lemon juice, salt, sugar, and various additives like mustard, stabilizers, and flavor enhancers are added in a programmed sequence. Have you ever wondered why a bit of mustard appears in mayonnaise recipes? It's not there to add the spicy kick you'd expect in a hot dog. Instead, it rounds out the flavor, adds depth, and more importantly, it helps emulsify. The amount is so small you might not notice it's there, but take it away, and you'll feel like something's missing, even if you can't quite explain what. Finally comes the refined vegetable oil, most commonly soybean oil, which accounts for 65 to 80% of the total mixture and plays a key role in giving mayonnaise its rich texture and creamy body. Soybean oil is chosen for its neutral flavor, excellent emulsifying ability, and high stability. Before being used in production, the oil undergoes a thorough refining process, including deodorization, decolorization, and impurity removal to ensure absolute purity. This level of refinement helps create mayonnaise with a smooth, creamy texture, an appealing ivory white color, and an extended shelf life. Once all the ingredients have been added in the correct order and roughly blended, the mixture enters the emulsification stage, the most critical step in the entire production line. Here, high-speed mixing equipment, operating at up to 3,000 revolutions per minute, works continuously to disperse oil droplets evenly into the water phase. Egg yolk, naturally rich in lecithin, acts as a powerful emulsifier, stabilizing the structure of the mixture and preventing separation over time. In most modern systems, emulsification and homogenization happen at the same time, all inside one machine. As the high-speed mixer runs, it breaks down the oil into tiny droplets, that's homogenization, while the lecithin in the egg yolk wraps around those droplets and helps bind them with water. That's the emulsifying part. This combo gives the mayo its smooth, creamy texture and keeps it from separating over time. Once the process is done, the mixture gets pretty warm from all that mixing, so it's quickly cooled down to lock in the structure and preserve the fresh taste. Before entering the packaging stage, technicians collect samples of the mayonnaise for testing. The product must pass strict evaluations for viscosity, pH, color, taste, and emulsion stability to ensure consistent quality and food safety. At the same time, microbiological tests are also carried out to detect and eliminate any risk of contamination. After passing rigorous quality checks, the finished mayonnaise is pumped into various types of packaging, including plastic bottles, single-serve sachets, and glass jars, all carried out on a fully automated, closed-loop packaging line. For jars and bottles, automated filling systems dispense the mayonnaise with milliliter-level precision. In advanced facilities, the line can fill up to 15,000 bottles per hour, meeting the demands of high-volume global production. Once filled, each unit moves to the capping station, where lids are sealed tightly with even mechanical force to ensure an airtight seal. Labels are then automatically applied, displaying full traceability and expiration details. From filling to final packaging, every step takes place in a strictly controlled environment to ensure hygiene and precision, minimizing contamination risks and preserving product integrity until it reaches the consumer. For single-use sachets, the mayonnaise is dispensed and heat-sealed in a matter of milliseconds using high-speed sealing technology. The entire process from filling to sealing takes less than 1 second per unit. And from the very first egg to the final squeeze of sauce, every jar of mayonnaise is the result of cutting-edge technology, engineering precision, and meticulous care at every stage of production. However, that guilty feeling after the first spoonful is hard to avoid. Behind its smooth, rich, and creamy texture lies an energy bomb with nearly 100 calories per tablespoon, making mayonnaise one of those deceptively indulgent foods that can quickly lead to weight gain if you're not careful. Now imagine yourself standing in the middle of a sugarcane field that stretches all the way to the horizon, where towering, sturdy stalks reach up under the sun. Welcome to Brazil, the kingdom of sugarcane. Every year, this country grows over 700 million tons of sugarcane, more than anywhere else on Earth. But don't let the plant's humble appearance fool you. From this seemingly simple grass, humans have built a massive industry worth over $40 billion. And here's a sweet little fact you might not know. Just 10 sugarcane stalks are enough to produce a 1 kilogram bag of sugar. Compared to other crops like corn, wheat, or fruits, which contain less than 10% sugar, sugarcane stands out with a natural sugar content of up to 16%, making it one of the sweetest and most efficient raw materials for sugar production. And it all begins with the harvest season, when the sugarcane fields come alive, ready to kick off a brand new production cycle. Before the harvest season officially begins, farmers in many sugarcane growing regions choose to burn the fields. It might sound unusual, but the goal is to remove the dry leaves and unnecessary tops of the sugarcane. This practice helps clean the stalks, reducing the amount of unwanted material like fallen leaves, organic debris, and insects, which in turn makes the harvesting process quicker and more efficient. Plus, collecting only the sugar-rich stalks helps cut down on transportation costs. However, because this method produces a significant amount of smoke and harmful emissions, sugarcane burning is now strictly regulated. In some areas where it's still allowed, burning must follow specific timeframes and environmental conditions to minimize its impact on air quality and public health. In light of these concerns, harvesting fresh, unburned sugarcane using modern machinery is increasingly being encouraged and is quickly becoming the new standard. Sugarcane harvesters are engineered with high precision, capable of cutting close to the ground without damaging the roots, allowing the plant to regenerate for future harvests. As the machine moves along the rows, a system of sharp, continuously rotating blades slices the cane stalks cleanly. At the same time, the leaves and tops are removed directly on board using a smart separation system combined with powerful fans. These unwanted parts are returned to the field, forming a natural mulch layer that helps retain soil moisture and boosts fertility. The valuable cane stalks, rich in sugar and economic value, are pre-processed on the spot, cut into short segments, and sent to a large holding chamber at the back of the machine. A modern harvester can handle between 80 to 120 tons of sugarcane per hour, equivalent to the workload of dozens of manual laborers. This significantly speeds up the harvest process, cuts costs, and is especially well suited for large-scale sugarcane farms. Once full, the chopped cane is swiftly transferred to waiting trucks at the edge of the field, ready to be transported straight to the factory. This ensures the cane remains fresh and retains its optimal sugar content. After harvesting, millions of tons of sugarcane are transported to the factory by truck or train, depending on the region. The cane must be delivered to the mill as quickly as possible to prevent dehydration and loss of sweetness. Juice samples from different farms are collected separately and analyzed in on-site laboratories to determine the sugar content of each batch. Before processing begins, the sugarcane is passed through a high-pressure water spray system to be thoroughly washed. This step removes soil, sand, dust, and any remaining impurities clinging to the cane stalks, ensuring the raw material meets the necessary cleanliness standards. Thorough cleaning not only protects the crushing equipment from damage, but also plays a crucial role in preserving the quality of the raw sugarcane juice, the primary ingredient used to produce sugar. After being washed, the long sugarcane stalks are fed into specialized cutting machines to be chopped into smaller pieces. The stalks are cut into short segments to make them easier to feed into the crushing system. On its way to the crushing machine, each cane stalk passes through a set of interlocking metal gears that tear it apart. With a processing speed of up to 30 tons an hour, this system keeps the factory buzzing non-stop. If you still can't picture how much that is, one dairy cow would need around 40 days to chew through that much sugarcane, assuming she doesn't get bored and wander off halfway through. Next, these pieces pass through powerful crushers equipped with heavy rollers that continuously press and squeeze the cane to extract raw juice. Thanks to this roller system, the sugar content is extracted as efficiently as possible, maximizing the output of the entire process. Once the crushing is done, the leftover dry pulp, known as bagasse, is far from waste. Instead, it's smartly collected and reused. Meanwhile, the raw cane juice becomes the key ingredient for the next stages of refined sugar production. Have you ever experienced the scent of a mountain of sugarcane pulp filling the air? I bet it's one of the sweetest and most soothing smells that could ever make you feel truly satisfied in life. And now, prepare to be amazed by how factories make almost full use of sugarcane bagasse, turning it into eco-friendly products like plates, cups, and even paper. The bagasse is then collected and transported to specialized recycling facilities by truck or through a centralized transfer system. At the recycling plant, the bagasse goes through a high-pressure water washing system to remove impurities like soil, sand, shredded cane peel, and any remaining sugar. After washing, it is either mechanically pressed or lightly dried to prepare it for the grinding stage. Once cleaned, the bagasse is fed into grinding machines to break down its fibrous structure. The resulting mixture is then cooked at high temperatures, sometimes with a small amount of natural additives like starch or recycled paper pulp to enhance the material's stickiness and flexibility. The processed bagasse pulp is poured into pre-designed heated metal molds, shaped like plates, cups, bowls, or food containers. Here, the hot pressing process takes place at temperatures ranging from 160 to 200 degrees Celsius. Under the combined effect of heat and pressure, the pulp gradually hardens and takes the shape of the mold, while any remaining moisture is evaporated. As a result, the product not only forms a fixed shape, but also gains a stable, firm surface, ready for the next finishing steps. After molding, the semi-finished products go through a final drying stage to reduce moisture content to below 8%. Next comes the finishing stage, where excess edges are trimmed and the rims are smoothed to ensure both visual appeal and safe use. Finally, a water-resistant coating made from bio-based materials or plant-based wax is sprayed onto the surface, allowing the product to safely hold hot or liquid foods. The finished products undergo quality inspection and are then packaged using paper or cardboard materials to minimize environmental impact. From there, these bagasse-based plates, cups, and containers make their way to supermarkets, food stores, or restaurants. In reality, products made from sugarcane bagasse can biodegrade within 60 to 90 days and are considered a much more environmentally friendly option compared to plastic, which takes 500 to 1,000 years to decompose and is one of the biggest environmental challenges today. But the issue is, bagasse products require proper industrial composting conditions to decompose that quickly. If they are thrown into regular landfills, the decomposition time can sometimes be even longer. And now, let's dive into the most anticipated part, the sugar factory, where those sweet drops of sugarcane juice are transformed into the pure white sugar crystals we use every day. After crushing, the raw sugarcane juice still contains fine impurities like fibers, dust, and organic residue. To purify it, lime is added to the juice. The lime reacts with the impurities, causing them to precipitate out, making the juice clearer, a crucial step before concentration. Next, the juice enters a multi-effect evaporation system, typically made up of 3 to 5 connected evaporators. In this system, water is gradually removed by heating the juice at temperatures ranging from 70 to 150 degrees Celsius, depending on each stage and the pressure inside. Through this process, the juice thickens and turns into a pale yellow syrup with a noticeably denser consistency. This concentrated syrup sets the stage for the crystallization step, where sweet crystals begin to form from the thick golden liquid. To begin the crystallization process, seed sugar crystals are added to the concentrated syrup, which is then slowly cooled. Over several hours, sugar gradually begins to crystallize. The resulting mixture is then transferred to a centrifuge, which spins at high speed to separate the sugar crystals from the remaining molasses. This is the key step that defines the difference between raw brown sugar and refined white sugar. A question many people have long wondered about. Brown sugar retains about 3 to 5% of natural molasses, giving it a rich brown color and a distinctive caramel-like aroma, while white sugar is refined to the point that it contains up to 99.9% pure sucrose, resulting in its bright appearance and clean, pure sweetness. After centrifugation, the sugar crystals are still slightly moist, so they are sent into a drying system to remove all remaining moisture. This prevents clumping and extends shelf life. Once dried, the sugar is ready to move on to the refining stage, where it will be purified to achieve its final sparkling white form. To produce pure white sugar, a decolorization process is carried out. First, raw refined sugar is dissolved in hot water at around 80 degrees Celsius. The solution is then heated and filtered through layers of sand and gravel, followed by activated carbon columns to remove the color. Finally, the solution is centrifuged once more to obtain pure white sugar crystals. Once the pure white sugar crystals are obtained, they are cooled and fed into a fully automated packaging line within a sealed, hygienic environment. The first step is precise weighing. Electronic scales measure out exact portions based on preset weights. Next, the sugar is dispensed into preformed plastic bags. These bags are pulled continuously from large PE film rolls cut to size and sealed with heat. This process is incredibly fast. Dozens to hundreds of bags can be packed every minute. After sealing, the bags pass through a metal detector to ensure no foreign objects are present. Once approved, the bags are printed with expiration dates and traceability codes, then packed into large cardboard boxes for distribution to the market. China is currently the world's leading producer of peanuts, with over 19 million tons harvested annually. But when it comes to peanut butter, the crown goes to the United States. Every year, more than 1.5 billion jars of peanut butter are produced in the US, accounting for nearly 40% of global output. In America, peanut butter isn't just food, it's a national breakfast icon. With industry giants like Jif and Skippy, the U.S. peanut butter market never goes out of style. Jif wins hearts with its velvety, smooth texture and rich, slightly sweet flavor that's downright addictive. Skippy, Jif's lifelong rival, boasts a massive base of loyal fans thanks to its bold taste and signature crunchy varieties that are impossible to mistake. And which peanut butter brand are you a big fan of? As for me, I'll always choose Teddy. It's been a part of my childhood ever since my school days, and every bite brings back sweet memories. Each year, the peanut butter industry generates over $5.7 billion for the global economy. It's more than a food product. It's a multi-billion-dollar game of flavor, branding, and nostalgia. From a tiny seed to clusters of golden peanuts hidden beneath the soil, the peanut plant requires 120 to 150 days of careful tending. Around September each year, in the state of Georgia, proudly known as the peanut capital of the world, vast peanut fields awaken from their summer slumber and enter the most vibrant and bustling harvest season of the year. The harvest begins with the arrival of digger-shaker machines, mechanical giants equipped with ultra-sharp blades that plunge swiftly into the ground. These machines gently shake the plants loose from the soil and flip them over, exposing the roots so that the golden peanuts can bask under the sun for natural drying. Working at an impressive pace, each digger-shaker can handle 10 to 15 hectares of peanuts per hour. After being flipped, the peanuts are left to sun-dry in the field for 3 to 5 days, depending on weather and humidity, to reach the ideal moisture level before collection. Next, combined peanut harvesters take over. Using rotating fans and soft vibrations, they separate the peanuts from the plants without cracking or damaging the shells. The stems and leaves are left behind in the field, not as waste, but as organic mulch to nourish the soil for the next planting season. And the peanuts? They roll along conveyor belts into massive hoppers that can hold up to 10 tons per load. Once full, the peanuts are transported to collection points near the fields. Each truck can carry up to 30 tons per trip, delivering the harvest to processing plants or climate-controlled storage facilities where temperature and humidity are closely monitored. Here, each batch of peanuts is tested for moisture content using specialized sensor systems. If the moisture level exceeds 10%, the peanuts are sent into state-of-the-art drying chambers where they are gently heated at a stable temperature of 35 to 40 degrees Celsius for 24 to 48 hours, just enough to dry them evenly without losing their natural flavor. Once dried, they are stored in climate-controlled warehouses, with the environment maintained at 10 to 15 degrees Celsius and humidity kept below 65%. Under these ideal conditions, the peanuts can be safely preserved for 3 to 6 months without any loss of quality. When ready, the peanuts are loaded onto large transport trucks with a capacity of 20 to 25 tons, ready to head to the main processing plant. Ever wondered what happens next once the peanuts arrive at the processing plant? The answer might just surprise you. The moment they set foot inside, the peanuts are fed into a high-speed vibrating sieve system, operating at 300 to 500 vibrations per minute. Thanks to this continuous shaking motion, Dust, broken shells, and impurities are effectively removed, leaving behind clean, whole peanuts, ready for their transformation. Next, they move along an automated conveyor belt to the shelling machine, where the outer shells are stripped away using steady air pressure of about 5 to 8 bar. Though the shells may seem tough and stubborn, they are removed in a matter of seconds with surprising precision. A powerful suction fan then immediately pulls away the discarded shells, leaving behind intact peanut kernels, perfectly rounded and ready for the next stage of sorting. Think selecting the finest peanuts is all up to machines? Not quite. This is where cutting-edge technology and human expertise join forces to create a surprisingly meticulous process. First, the peanuts pass through a state-of-the-art optical sorter, equipped with high-speed sensors and cameras capable of scanning up to 5,000 kernels per minute. A smart airjet system instantly blows away any peanuts that are cracked, insect-damaged, or substandard, keeping only the best of the batch. But that's just the machine's part. Next comes the sharp eyes and steady hands of experienced workers who inspect every peanut with precision. Using their trained instincts and swift fingers, they remove any shriveled or broken kernels, ensuring that only peanuts meeting the highest standards of size, color, and integrity move on to the next stage. After passing every strict quality check, the peanuts are finally ready for their last resting phase before being transformed into creamy, aromatic peanut butter. They are packed into large 50-kilogram sacks and moved into the factory's storage facility. Here, the peanuts are kept under stable conditions for about 2 weeks, allowing them to rest, balance their moisture levels, and preserve their natural flavor. It may seem like a small step, but this short pause is essential to ensure each future batch of peanut butter meets the highest standards of taste and quality. After their resting period in cold storage, the finest peanuts embark on an entirely new chapter of their journey. Now, let's follow the process step by step to discover how these humble little peanuts are turned into a beloved spread enjoyed by millions around the world. Every great journey begins with purity, and for peanuts, it all starts with a thorough wash. Once removed from their sacks, the peanuts are fed into rotating drum washers equipped with high-pressure spray nozzles. There, powerful streams of water blast away dirt, dust, and any lingering impurities. Clean and spotless, the peanuts are then moved into massive industrial roasters, where they're evenly roasted at temperatures between 160 to 177 degrees Celsius for 25 to 30 minutes. This step not only dries them completely, but also unlocks their natural aroma, intensifies that rich, nutty flavor, and forms a light, crispy outer layer, the secret behind the irresistible depth of every spoonful of peanut butter. After emerging fragrant from the roaster, the peanuts enter one of the most delicate stages of their transformation, the removal of the papery skins. They are fed into a modern deskinning machine that uses high-pressure air jets, 6 to 8 bar, combined with finely grooved rollers. As the peanuts pass through, the strong airstream blows away the thin outer skins, while the rollers gently massage the peanuts to loosen the shells without damaging the kernels. Next, the peanuts glide onto a vibrating conveyor, where a high-powered suction system removes any remaining skin fragments. What's left are clean, glossy peanut kernels, nearly perfect in appearance. But the process doesn't stop there. Before moving on to grinding, the peanuts go through one final round of optical sorting. High-speed cameras and image sensors scan 5,000 to 7,000 peanuts per minute, and any substandard kernel is instantly removed with a blast of air. Only the finest peanuts make it to the last step. Now everything is ready. The spotless, high-quality peanuts, having passed through rigorous screening, are officially entering their magical transformation stage, becoming smooth, creamy peanut butter. The peanuts are fed into high-capacity rotary grinders, where steel shafts rotate at incredibly high speeds, up to 3,000 RPM, generating intense friction to break down each peanut into a rich golden-colored paste. This critical step releases the nut's full aroma, natural oil content, and creamy texture. At this point, each factory adds its signature flavor formula, perhaps a pinch of salt to balance the taste, a bit of sugar to soften the finish, or vegetable oil to enhance the smoothness. All ingredients are precisely measured per batch using automated electronic weighing systems to ensure consistent quality and flavor. Once blended, the mixture enters industrial cooking kettles and is heated to a stable temperature between 71 to 82 degrees Celsius. This range is hot enough to eliminate harmful bacteria, yet gentle enough to preserve the peanut's natural flavor and achieve the perfect consistency. The heating process typically lasts 5 to 10 minutes and is closely monitored with thermal sensors. When the mixture reaches peak creaminess, aroma, and thickness, the hot peanut butter is pumped through insulated pipelines into holding tanks, ready for the final step: automatic packaging and distribution to consumers around the globe. And finally, the hot peanut butter is transferred to the automated packaging area. Here, a modern filling system pours the butter into glass or plastic jars, typically ranging from 250 grams to 1 kilogram in size. The jars are then tightly sealed and rapidly cooled to preserve their full flavor. Next comes labeling, final quality checks, and packing into boxes, ready to be shipped to consumers around the world. The entire packaging process takes place in a sterile environment, strictly adhering to food safety standards. As a result, every jar of peanut butter that reaches consumers is guaranteed to be fresh, safe, and consistently high in quality, ready to win over even the most demanding markets. Did you know that in the US alone, 97% of households have at least one bottle of ketchup in their kitchen? Heinz, the giant of the ketchup world, ships out up to 650 million bottles annually, making the United States the largest ketchup producer in the world. All thanks to a secret recipe we'll uncover in this video. Is there a food you just can't enjoy without a splash of ketchup? Drop a comment below. We're betting burgers and fries might have something to say. Every August, tomato fields enter their busiest harvest season of the year. Harvesting tomatoes is surprisingly similar to picking perfectly ripe grapes. It must be done gently, but with great precision. As the machine rolls in, its front conveyor system slowly lowers, carefully sliding under the dense tomato vines. The ripe, red tomatoes are gently lifted to avoid any bruising or damage. Then the shaker system kicks in, creating steady vibrations just strong enough to detach the tomatoes from their stems without compromising their quality. At the same time, the rear fan system roars to life. A powerful but controlled gust of air blows away leaves and small branches, leaving behind only the plump, ripe tomatoes. Any green or damaged fruits are automatically pushed off the conveyor and dropped into a rejection zone. The vibrant red tomatoes continue flowing smoothly down the main conveyor belt, forming a river of crimson color. One modern machine can harvest up to 15 tons of tomatoes per hour, making the entire process remarkably fast and efficient. Incredible, isn't it? The selected tomatoes roll toward the end of the conveyor belt, where a mechanical arm extends from the machine's side. A cascade of tomatoes pours into a waiting trailer. One by one, the trailers fill up with juicy red tomatoes, ready for the next leg of the journey, the factory. Once harvested, thousands of fully loaded trucks rumble toward the processing plant, carrying mountains of ripe red tomatoes. At the factory, the tomato-filled trailers are emptied into massive bubbling water tanks. Gentle streams of air bubbles rise up through the water, softly massaging each tomato, helping to remove stems, dust, soil, and other surface debris. This process not only cleanses the tomatoes, but also protects their delicate skins, preserving their freshness and vibrant red color. After the initial soak, the tomatoes move onto a conveyor and pass through high-pressure water jets. These powerful sprays blast away any remaining dirt, ensuring each tomato is sparkling clean and ready for processing. With a processing capacity of up to 20 tons of tomatoes per hour, this step is both highly efficient and essential for maintaining product quality at the industrial scale needed for ketchup and tomato sauce production. The brilliant red tomatoes rush along the conveyor in steady waves, creating a living sea of red, ready to move into the next stage of transformation. Once washed, the tomatoes pass through an automatic sorting system. Color sensors and laser scanners detect and remove any bruised, rotten, or unripe tomatoes. Using either air jets or mechanical arms, the system pushes defective fruits off the conveyor. Meanwhile, factory workers provide a final inspection, ensuring that only perfectly red, ripe, and evenly sized tomatoes move on to the next phase. After being sorted, the tomatoes are sent into a steam blanching system at a temperature of approximately 85 to 90 degrees Celsius for nearly 1 minute. The hot steam softens the skin, making it easier to peel without losing the essential nutrients inside, while also preserving the fruit's natural color and flavor. Immediately afterward, the tomatoes are rapidly cooled with cold water to halt the ripening process and maintain their freshness. This cooling process also helps loosen the skin more effectively. Next, the tomatoes are transferred onto a conveyor belt equipped with specialized rollers that gently remove the skin without damaging the flesh, ensuring high quality for the subsequent processing stages. Once peeled, the tomatoes are sent into industrial grinders where they're transformed into a thick, smooth puree. Stainless steel blades spin at high speed, turning the fruit into a consistent, rich mixture. This puree then passes through a specialized filtering system that removes seeds, fibers, and pulp. What remains is a silky blend of tomato flesh and juice, the golden base for creating tomato sauce and ketchup. In the tomato sauce production process, the tomato pulp and juice extracted after grinding are transferred into large cooking tanks. The mixture is simmered at a temperature of 85 to 95 degrees Celsius for about 1 hour to deepen the flavor and evaporate excess moisture. Compared to ketchup, tomato sauce is cooked longer to preserve its natural texture and original taste. As the mixture begins to thicken, ingredients like olive oil, salt, sugar, minced garlic, and herbs are added to enhance the sauce's natural flavor profile. After going through the cooking, fine filtering, and seasoning adjustment process to achieve the perfect flavor, tomato sauce is immediately transferred to the sterile packaging area. Before coming into contact with the sauce, All glass bottles or tin cans must undergo a thorough cleaning process. Once the packaging is ready, the automatic filling system kicks into action. Thanks to smart dosing technology, each bottle or can is filled with a precisely measured amount of tomato sauce, ensuring consistency while preventing overfilling or shortage. After filling, the containers pass through a vacuum sealing machine. Removing all the air from the packaging helps prevent oxidation and limits the growth of microorganisms. Immediately afterward, the bottles or cans are sealed tightly using a heat press system or automatic capper. Even though the process so far has been rigorous, to guarantee absolute food safety, the sealed products are then sent to a high-temperature sterilization system. Finally, the delicious bottles of tomato sauce are neatly arranged and moved to cold storage rooms kept at temperatures between 4 to 10 degrees Celsius. Thanks to the cool and dry environment, the sauce can retain its full flavor, color, and quality for 6 to 12 months. Ready to serve everything from home-cooked meals to large-scale commercial kitchens. During ketchup production, the tomato pulp and juice are cooked at higher temperatures, but for a shorter time compared to tomato sauce, around 90 to 100 degrees Celsius for approximately 45 minutes. This method helps retain the ketchup's fresh and tangy flavor. Heinz's legendary status is often credited to its perfectly balanced recipe, said to its 72 to 75% concentrated tomatoes, 12% distilled vinegar, 10% natural cane sugar, and other natural ingredients. This combination creates the signature sweet tangy taste and velvety texture that's hard to beat. Once the cooking is complete, the ketchup is sent through a high-pressure homogenizer to achieve a perfectly smooth and uniform texture. After rapid cooling, Heinz ketchup enters its final stage, packaging. Plastic bottles are the most commonly used packaging format for Heinz. An automated precision filling system dispenses the ketchup into each bottle with high accuracy, ensuring consistent volume and quality across every unit. Next, a screw cap or flip-top lid with a protective seal is applied and tightly secured to preserve freshness and prevent air from entering. The bottles are then labeled and printed with the production and expiration dates using an automated labeling system. Thanks to this meticulous and hygienic packaging process, Heinz has continued to deliver consistent quality and its signature flavor, unchanged for more than 150 years. France is hailed as the wine capital of the world, the birthplace of timeless legends like Bordeaux and Champagne. Each year, the country produces over 4.5 million tons of wine, securing its place at the top of the global stage. Its vast vineyards are not only the soul of French agriculture, but also a treasury of culture, art, and culinary heritage. Wine defies the notion that intoxication can only be born from formulas repeated for millennia. Instead, nature has gifted the world with a unique marvel, ice wine, crafted from grapes frozen at 7 degrees Celsius. As the frost extracts the water, what remains is a rare, concentrated nectar of sweetness and purity, turning each glass into a vivid testament of harshness transformed into beauty. In the realm of luxury wine, as much as 20% is believed to be counterfeit, a figure even higher in the fine wine segment, including such illustrious names as Bordeaux and Burgundy. Yet many bottles still fetch millions at auction, only to remain sealed, for a single uncorking could shatter their value and expose the truth behind the glittering facade. And like every legend, that journey begins in sun-drenched vineyards, where each plump cluster of grapes is cherished as nature's treasure. As autumn arrives, a gentle breeze sweeps across the endless rows, while golden sunlight reveals the fullness of each grape. The moment that marks the start of harvest season, heralding the opening notes of an endless symphony of wine. For grape varieties used in table wines, mechanical harvesting is considered the optimal solution, boosting productivity while reducing labor costs. In countries with highly mechanized agriculture, such as the United States, especially California, which accounts for over 90% of the nation's grape production, most vineyards rely on advanced machinery for harvesting. These machines are equipped with soft vibration systems and precise sensors, creating gentle oscillations just strong enough to detach ripe clusters from the vine without damaging the fruit or the plant. As the grapes fall, they are caught by padded catchers lined with elastic material, then transferred smoothly onto conveyor belts. Thanks to this design, even the most delicate grapes retain their shape and quality. Each machine can harvest up to 9 tons of grapes per hour, many times faster than manual labor, while still preserving the freshness and flavor of the fruit. In long-established wine regions such as France, Italy, and Spain, where grapes are destined for fine wines or fresh consumption, human hands still play a crucial role in the harvest. This work demands precision and patience. Harvesters carefully walk row by row, using specialized shears to cut clusters at the perfect ripeness, then gently place them into soft baskets or cushioned crates to prevent bruising. Though time-consuming and labor-intensive, this traditional method offers an irreplaceable advantage. Each grape retains its shape, color, and flavor, meeting the most stringent standards for premium wines and high-end markets. And when the harvest season ends, it marks the beginning of a new and promising journey for these grapes. Before being transformed into refined bottles of wine, part of the grape harvest takes a different turn, one that is sweet and full of surprises. From sun-drenched clusters, the grapes quietly evolve into raisins, nature's candies, crystallized from light and time, preserving the pure essence of the earth and sky. Raisins are most often made through natural sun-drying, a process that seems simple, yet plays a crucial role in preserving their distinctive flavor. In major production hubs such as California, Turkey, and Iran, where the climate is hot and dry with abundant sunshine, grapes are spread out on cement floors, mats, or hanging racks for 2 to 3 weeks. During this time, the water inside the grapes slowly evaporates, leaving behind an increasingly concentrated natural sweetness. Some regions employ a special method, allowing grapes to dry directly on the vine before harvesting, producing raisins that are darker in color and richer in flavor. When the grape's moisture content drops to around 15 to 18%, the standard for commercial raisins, farmers collect them and send them to processing facilities for the next stage of post-harvest treatment. When the raisins arrive at the processing plant, the first step is preliminary screening. A vibrating system combined with suction fans removes dry leaves, stems, soil, and other large impurities. This is a crucial preparation stage before the raisins undergo more thorough washing. After screening, the raisins are cleaned using a high-pressure water spray system. Powerful water jets wash away all remaining dust and bacteria from the surface of the fruit. With a capacity of up to 10 tons per hour, this system ensures the washing process is fast and effective, without affecting the texture or natural flavor of the raisins. Once cleaned and carefully sorted, using both optical technology and skilled human inspection, the qualified raisins are transferred to a modern packaging line. Here, the raisins, after being thoroughly cleaned and sorted, are directly packed into large, sturdy cartons that ensure safety during storage and transportation. Thanks to a modern automated boxing system, the products are swiftly completed and made ready to be shipped worldwide, bringing their natural flavor to millions of consumers. And now comes the most anticipated moment, the journey of transforming luscious, fresh grapes into enchanting wine. From classic bottles steeped in memories to refined modern flavors, every secret behind the winemaking process will be unveiled, right here, right now. The story begins as massive trucks, loaded with freshly harvested ripe grapes, roll into the winery's receiving area. Here, the grapes are emptied into giant stainless steel tanks before being swiftly carried along a modern conveyor system, where speed and gentleness work hand in hand to preserve the fruit's quality to the fullest. A remarkable aspect of winemaking is that the grapes are never washed with water. On their skins lies a precious layer of natural yeast, essential to fermentation and responsible for the wine's unique character, something no technology could ever replace. Washing it away would strip the wine of both its flavor and its soul. Instead, the grapes are carefully cleaned by hand. Workers meticulously remove every stray leaf, stem, or damaged fruit, preserving the grape's natural living essence. Immediately after, they continue their journey along sorting conveyors, where sharp eyes and skilled hands examine each grape with precision. Any fruit that is bruised, discolored, or falls short of the standard size is discarded. Only the most flawless clusters are chosen to embark on the journey of becoming that legendary liquid we call wine. After being carefully selected, the grapes are passed through a specialized machine for the destemming process. This modern procedure uses advanced equipment to separate the stems from each cluster without damaging the fruit. Once freed from their stems, the grapes are gently moved on to the next stage. Following destemming, the grapes are sorted once again, this time by an optical system equipped with cameras and special lighting. Using image scanning and infrared technology, the system analyzes each individual grape with precision, automatically removing those that do not meet the required standards to ensure top-quality output. This technology can handle up to 20 tons of grapes per hour, streamlining production and improving efficiency. The carefully selected grapes then move into massive crushing machines, capable of processing up to 10,000 pounds per hour. Inside, finely engineered rollers and rotating paddles gently press the grapes, keeping the seeds intact, because if a seed were to break, bitterness would seep into the wine. After pressing, the grape juice is transferred into massive fermentation tanks, where the true magic of wine begins. Over the course of 10 to 30 days, natural yeasts quietly transform sugars into alcohol and carbon dioxide, causing the grape skins to rise and form a dense fermentation cap. To infuse the wine with rich color, aroma, and tannins, this cap must be regularly pushed back down, a rhythmic dance between human hands and nature. Once fermentation is complete, the wine undergoes clarification and separation to remove skins, seeds, and any remaining impurities. With the aid of specialized filtration systems, the pure wine gradually emerges, becoming clearer, brighter, and more refined. This step not only eliminates the risk of bitterness or off flavors, but also paves the way for the wine's character to fully develop. From here, the wine is transferred into aging vessels, ready to continue its journey toward becoming a legendary liquid. For fine red wines, after filtration, the wine is moved into oak barrels for aging, the place where the true miracle unfolds. Carefully pumped into the wooden casks, the wine will rest for anywhere from 12 months to over 2 years. During this time, the oak imparts its distinctive aromas while softening the natural tannins, resulting in a velvety structure and profound depth in every sip. At last, when the wine has reached its maturity, the most delicate journey begins: bottling. A wine bottle is not merely a container, but a home that defines its preservation and aging. The color, green, brown, or clear, is chosen to shield the wine from light, while the shape, Bordeaux, Burgundy, or Champagne, reflects both region and style. Then comes the closure, the traditional cork that allows subtle breathing, the modern screw cap that guarantees a tight seal, or, in the case of sparkling wines, a thick cork reinforced with a wire cage to withstand pressure. Throughout the process, oxygen control is paramount. Too much causes premature aging, too little suffocates the wine within. Finally, automated machines can fill up to 3,000 bottles per hour with milliliter precision before labeling, sealing, and sending this preserved flavor to every corner of the world. From sun-drenched vineyards to the shimmering glass on the table, the story of each drop of wine is a legacy of land, time, and tireless hands. Over thousands of years, this sweet fruit juice has transformed from ancient ritual to a modern emblem of refinement. And today, in a single sip, one can taste both tradition and innovation, intertwined in the most captivating way. Before modern cigarettes came into existence, humans had been using tobacco leaves for thousands of years. In ancient Mayan culture, tobacco was considered a sacred gift to the gods. By the 16th century, it had followed European explorers to the New World, then spread across the globe, becoming intertwined with colonialism, war, and the glamour of Hollywood. You may have never seen a tobacco plant with your own eyes, but every year, the world still harvests over 6 million tons of tobacco leaves, fueling an industry worth nearly $900 billion. China currently leads in production with more than 2.6 million tons annually, but the most famous tobacco brand in the world comes from the United States, Marlboro, which accounts for up to 14% of global consumption. And you, what's your number one brand? And every great story has a beginning. For this smoky muse, it all starts in the sun-drenched tobacco fields, where warm summer breezes signal the first whispers of harvest. From around July to September each year, the tobacco fields enter harvest season. Harvesting requires great precision, relying on both experience and traditional principles. Specialized machines move slowly through the head-high rows of plants. Beneath them, a system of sharp rotating blades precisely cuts the mature leaves close to the ground. Immediately afterward, soft conveyors receive and lift the leaves, preserving their shape and moisture while minimizing tearing or bruising. Leaves must be picked when they are not too wet to prevent bruising, yet not too dry, which makes them brittle. The ideal temperature is between 20 to 25 degrees Celsius, and harvesting typically takes place between 5 and 9 a.m., when the leaves are still supple and retain a healthy sheen. The leaves are delivered directly into a large ventilated container at the rear, designed to prevent moisture buildup and premature fermentation. Once full, an automatic unloading system transfers the leaves to a detachable bin or a specialized truck moving alongside. On average, a single machine can harvest about 5 tons of fresh leaves per day, 8 to 10 times more efficient than manual labor, while also reducing risks and improving efficiency across the entire production chain. At some cigar tobacco farms, machines are used to harvest the entire plant. These devices cut the stalk at the base, gently lift the full row, and automatically hang the plants onto integrated curing racks, ready for drying. Notably, keeping the stalk intact allows sap to continue distributing into the leaves during drying, making them softer, more elastic, and rich in natural oils, crucial qualities for producing smooth, flexible, and glossy wrappers for premium cigars. In Cuba, Nicaragua, and the Dominican Republic, the birthplaces of hand-rolled cigars, the tradition of harvesting by hand is still carefully preserved, serving as a tribute to the leaves that will become the soul of premium cigars. Unlike the mechanical precision of machines, manual harvesting follows a slow, deliberate rhythm rich with craftsmanship. Skilled workers closely examine each leaf, using its color, sheen, and elasticity to judge the perfect stage of ripeness. After harvesting, the leaves are bundled into small groups and placed in woven baskets or breathable racks to maintain their shape. Though labor-intensive and slower, this meticulous process is what gives handmade cigars their unique value. Why a single premium cigar can fetch hundreds of dollars, while a pack of machine-made cigarettes costs just a few. From here, the leaves begin to diverge, some destined to become artisanal cigars, others entering the industrial pipeline of mass-market tobacco. Let's begin with the remarkable story behind every cigar. Not just something to smoke, but a product born from time, technique, and traditional craftsmanship. Immediately after being harvested, tobacco leaves enter the curing stage, the first and one of the most critical steps in cigar production. The leaves are hung in curing barns or sheds, where temperature, humidity, and airflow are tightly controlled. Depending on the leaf variety and desired flavor profile, different methods may be used. Sun curing, air curing, smoke curing, or heat curing. This process usually takes several weeks and requires great precision, as even small deviations can significantly impact leaf quality and the final cigar flavor. After curing, the properly dried tobacco leaves move on to fermentation, an essential stage for refining flavor and stabilizing leaf structure. The leaves are stacked into large piles called pilones, where heat naturally builds up through biological decomposition. During this phase, unwanted compounds such as excess nicotine and ammonia are removed, while natural aromas are enhanced. Workers regularly turn the piles to control temperature and humidity, and lightly moisten the leaves to maintain optimal conditions. Once fermentation is complete, the tobacco leaves are carefully sorted based on size, color, softness, and flexibility. Each cigar requires 3 types of leaves: the wrapper, outer layer, the binder, middle layer, and the filler, inner core. The wrapper is the outermost leaf, directly impacting the cigar's appearance and flavor. The binder holds the filler together, providing structure, while the filler, the heart of the cigar, is made up of several smaller leaves blended according to a specific recipe. This filler blend is what gives each cigar its unique flavor profile and signature character. For premium cigars like those from Cuba or the Dominican Republic, hand-rolling remains the gold standard. Skilled artisans carefully select the appropriate filler leaves, arrange them according to a specific blend, then roll them tightly with a binder and finish with a smooth wrapper. Each cigar is shaped, the head is twisted, then it's placed into a mold for pressing and undergoes thorough inspection before storage and packaging. While each artisan can roll only a few dozen to a few hundred cigars per day, their precision and craftsmanship result in a level of quality that's unmistakably superior. Although the cigars are already complete in appearance, they still require time to rest. This post-roll aging stage lasts from 2 weeks to 3 months, allowing the tobacco leaves to blend and the flavors to stabilize. During this period, the compounds in the filler, binder, and wrapper gradually harmonize, creating a balanced aroma, taste, and burn. As a result, the cigars reach their ideal state before being packaged and shipped. Meanwhile, in large-scale factories, automated cigar rolling machines are used to boost productivity and standardize the product. First, tobacco leaves are fed into the machine and cut to pre-programmed specifications. Once the filler, binder, and wrapper layers are precisely arranged, a system of rollers tightly wraps them into the shape of a finished cigar. The head of the cigar is then neatly twisted by the machine to ensure uniform size and appearance. Next, the cigars pass through a preliminary inspection line before moving on to the next stage. Specialized equipment is used to assess the roundness, firmness, and tightness of the cigar's head, as well as the condition of the wrapper surface. Any cigar showing defects, such as loose rolling, torn wrappers, or incorrect dimensions, will be rejected or redirected to a separate category for further handling. After that, each cigar is carefully wrapped in a thin layer of nylon to protect its outer structure, maintain optimal humidity, and ensure complete hygiene. This wrapping also helps shield the cigar from environmental factors during transportation and storage, preparing it for the final packaging stage. And now, let's explore the cigarette manufacturing factories, where each cigarette is produced through a closed-loop process that is both rapid and highly precise. Unlike the artisanal craftsmanship of hand-rolled cigars, cigarette production is highly industrialized, driven by extensive automation and advanced technology. Unlike cigars, which require each leaf to be hung individually, tobacco leaves used for cigarettes are typically stacked in large cages or mesh containers, then placed into sealed curing chambers with automated temperature and humidity controls. These high-capacity systems operate continuously and can cure several tons of leaves each day. The drying process removes moisture and stabilizes the leaf structure, preparing them for further processing. Once the leaves reach the desired moisture level, they are compressed into tightly packed bales for easy storage and transport to the main processing plant. At the factory, the tightly packed bales of tobacco leaves are unpacked and fed into a modern cutting system. Here, the leaves are shredded into fine, uniformly sized strands, making them easier to roll into paper and ensuring a consistent, even burn in every cigarette. These shredded tobacco strands are then moved into a blending process that follows a proprietary formula unique to each brand. In addition to the primary tobacco material, the blend may include several additives such as flavor enhancers, humectants, and aromatic agents, designed to smooth the draw, adjust the scent, and enhance the overall smoking experience. The entire process is strictly monitored and controlled to ensure uniformity and maintain the final product's quality standards. Once the tobacco filler is ready, the automated production line feeds it into specialized rolling paper tubes, ensuring an even burn and controlled smoke output. The processes of rolling, cutting, attaching the filter, and shaping the cigarette are all fully automated, producing thousands of cigarettes per minute with high precision. Once the finished cigarettes meet quality standards, they are transferred to a fully automated packaging line, a highly precise and tightly controlled process. Every 20 cigarettes are neatly aligned and inserted into a specially designed cardboard box. These boxes are built to withstand transportation while also clearly displaying the brand's colors and imagery. Next, each pack is wrapped in a layer of foil or thin aluminum film to preserve the aroma, block moisture, and shield the contents from environmental factors. This is followed by an outer shrink-wrap plastic layer, which enhances durability and gives the final product a sleek, polished look by the time it reaches the consumer. Thanks to advanced automation, modern factories can produce hundreds of thousands to millions of cigarette packs per day with near-perfect consistency. And that is the meticulous journey, from delicate leaves swaying under the sun and wind to the iconic product of a multi-billion-dollar industry. Are you curious about how farmers cultivate the vast tobacco fields behind the billions of cigarette packs produced each year? That journey begins with tiny seeds carefully germinated in soil trays or greenhouses, where light, temperature, and humidity are strictly controlled. After about 4 to 6 weeks, once the seedlings reach a height of 15 to 20 centimeters, they are transplanted into the fields. Today, instead of planting each seedling by hand, many modern farms use specialized tobacco transplanters. These machines can automatically drill holes, place the seedlings, cover them with soil, and gently press the surface, all in a single pass. Thanks to this technology, thousands of tobacco plants can be planted in neat, uniform rows within just a few hours, saving labor while ensuring optimal spacing between plants. Tobacco thrives in loose, well-drained, nutrient-rich soil. Throughout its growth cycle, chemical fertilizers, pesticides, and herbicides are frequently applied to prevent pests and diseases and to ensure the leaves meet commercial quality standards. However, the heavy reliance on these chemicals silently contributes to soil and water pollution, posing a serious threat to the surrounding ecosystem. An often overlooked dark side of cultivating one of the world's most profitable industrial crops. Now, each time you hold a cigarette in your hand, the smoke you exhale carries more than a habit. It embodies the essence of the earth, the sky, and the hands that shaped it. China, the undisputed king of the garlic world. Despite repeated allegations of using prison labor in its production chain, the country still churns out over 20 million tons of garlic every year, dominating more than 80% of the global supply and exporting to nearly every continent. And here's a fascinating fact you might not know. Garlic is an asexual plant. That means over the centuries, the quality and traits of the clove you're holding in your hand still carry the exact genetic imprint of its ancestors from generations past. But garlic isn't just biologically fascinating, it's nutritionally powerful too. It contains allicin, a powerful compound known to boost immunity, help prevent colds, and act as a natural biological shield that repels hungry insects in the fields, reducing the need for excessive pesticides. Interestingly, despite its humble nature, Americans aren't too fond of garlic cloves that look rough or imperfect. That's why Christopher Ranch cleverly tapped into this preference, focusing on producing higher quality, locally grown garlic. A strategy that helped the brand stand strong and weather the storm of cheap garlic imports from China. So, what do you think? Is overwhelming quantity or lasting quality the true measure of success in modern agriculture? And no matter where it's grown, the journey of garlic always begins in the fields, where around November, the first seed cloves are gently planted into the soil, marking the start of a slow but promising growing season. After about 7 to 8 months, when garlic fields begin to turn golden and the outer leaves start to dry, that's the familiar signal that farmers are about to reap the well-earned reward for their hard work. Harvest season has arrived. One key difference in garlic harvesting compared to other crops is that farmers deliberately stop irrigation a few weeks in advance, allowing the stems and leaves to naturally wilt in the field before bringing in the harvesting machinery. Unlike the heavy-duty machines used for harvesting potatoes, garlic is harvested using a specialized bulb harvester, a machine designed to gently dig up, lightly clean, and transport field-dried garlic bulbs in one continuous process, with minimal human handling. A thin, sharp cutting blade glides gently beneath the soil, lifting the garlic bulbs from the ground with precision. Immediately afterward, a vibrating shaft or shaker table helps shake off any remaining soil around the bulbs while also separating the dried stems and leaves. These dried plant parts, which hold no commercial value, are discharged at the back, either left to decompose naturally on the field or collected for composting. With high capacity, a machine like this can harvest between 10 to 20 tons of garlic per day, depending on soil type and bulb dryness. It's an ideal solution for large-scale garlic production areas that supply industrial processing chains, such as peeling, oil extraction, drying, or freezing. However, large-scale harvesting often leads to uneven quality, which is why, for the premium market, each bulb must be hand-harvested, because there's simply no place for misshapen or unattractive garlic cloves. After being pulled, garlic is arranged in neat rows on the field, with the bulbs facing inward, and the leaves overlapping to create shade, protecting them from harsh sunlight that could damage the skin or cause neck burn. Over about 5 to 10 days, the garlic gradually dries thanks to the sun and wind. Its skin tightens, becomes lighter in color, and its natural aroma becomes noticeably stronger. Garlic can only be harvested within a short window of a few weeks, as leaving it in the ground too long causes the bulbs to split, lose dryness, and diminish in flavor, making it crucial for farmers to complete the entire process within this narrow golden window to preserve crop quality. Although this process is more labor-intensive and time-consuming, it yields garlic bulbs that meet high commercial standards, easier to store, easier to sell, and more appealing to consumers who are willing to pay up to 50% more than the base price. At the end of the harvest season, truckloads of garlic roll toward the processing plant, where these pungent bulbs begin their next chapter, transforming into flavorful, convenient products, with enough punch to keep any vampire far, far away. As they arrive at the factory, tons of garlic still carrying the warm scent of sunlit fields are greeted by forklifts, unloading towering crates into the warehouse, a resting place before the bulbs begin their journey through a magical production process. After their resting time in the warehouse, each crate of garlic is gradually awakened and moved to the pre-processing area. Here, the bulbs are gently poured onto conveyor belts where everything begins to reveal their destined path. Rotating shafts then work to loosen and remove dirt and debris from the garlic bulbs, preparing them for the next steps in processing. In modern factories, sorting is carried out using a vibrating mesh system, where each garlic bulb rolls across screens with standardized mesh sizes. Only those with uniform size, dry skin, and no bruises make it through this first checkpoint. Amid the gentle hum of the conveyor line is a constant rhythm of inspection. As each garlic bulb passes through, it is carefully examined one last time before officially entering the path of processing. After clearing the initial screening, the garlic bulbs are further sorted based on their intended processing purpose, with criteria such as color, size, and skin condition. At this stage, no machine can replace the keen, experienced eyes of skilled workers who can inspect and make decisions on up to 200,000 pounds of garlic each day. The plump, dry-skinned garlic bulbs, playfully nicknamed beauty queens of the field, are sent to the whole bulb packing line, where their appearance is carefully refined down to the smallest detail. The garlic passes through a size sorting machine, a multi-tiered vibrating screen system with different mesh sizes. Smaller bulbs fall through to the lower tiers, while medium and large ones are retained on their respective levels. Each tier has its own chute, directing the garlic to corresponding packing stations, ensuring perfect uniformity in every finished bag. In large-scale factories, this system can process up to 3 to 5 tons of garlic per hour, without a single bulb being touched by human hands. Not every customer has the patience or time to peel each garlic clove individually, which is why pre-peeled garlic products were created to offer quick, convenient, and time-saving solutions for modern living. Their journey begins inside a spinning machine, resembling a giant wok, where each garlic bulb is gently, yet decisively caught in a swirling motion. This rotation causes the outer layers to peel away, revealing the cloves still tightly clustered together inside. Immediately afterward, each clove is guided into a steaming chamber, where warm steam envelops every surface, penetrating every crevice of the skin, softening the thin outer layer until it's ready to be peeled away. Next, the garlic passes over a vibrating table, where carefully calibrated air pressure gently loosens the peeling skin without damaging the pure white cloves inside. The loosened garlic skins are not wasted. Instead, they are collected and recycled as nutritious feed for livestock, contributing to sustainable farming practices. Immediately afterward, the garlic is passed through an optical sorting machine, a modern device that uses light technology to precisely inspect each clove, detecting and removing those with defects, damage, or that fail to meet standards for color and size, ensuring satisfaction even for the grumpiest consumers. Garlic that meets the stringent quality standards undergoes a thorough washing process to remove any remaining impurities, followed by careful drying to preserve its freshness and flavor, before being meticulously packaged and prepared for distribution to kitchens around the world. The innovative marketing strategy for pre-peeled garlic products has captured up to 25% of the market share compared to traditional whole garlic bulbs, even though this method may cause the garlic to lose some of its essence. The unique aroma of garlic will lead you on a different journey, slower, deeper, and ending with a fragrance that's truly unmistakable. First, once the garlic cloves have been carefully sorted to ensure uniformity, they are seasoned according to specific recipes that typically include olive oil, sea salt, black pepper, and aromatic herbs such as rosemary or thyme. These ingredients are carefully mixed to enhance the natural flavor of the garlic and add subtle layers of taste. The seasoned cloves are then evenly spread out on large trays or arranged meticulously on conveyor belts to ensure consistent roasting. Following this preparation, the trays or conveyor belts transport the cloves into the industrial roasting oven, where controlled heat and airflow work together to slowly and evenly roast the garlic to perfection. Like baking an apple pie, controlling the temperature is the most important factor. The roasting temperature and duration are carefully adjusted, typically ranging from 160 to 180 degrees Celsius for 20 to 40 minutes, to ensure the cloves cook evenly while preserving their flavor and tenderness. In that warmth and darkness, the natural sugars in the garlic gradually transform, creating a glossy honey-brown color. The sharpness nearly disappears, replaced by a mild sweetness, nuttiness, and a subtle smoky aroma, reminiscent of a mysterious savory jam. Although garlic offers many health benefits when consumed in moderation, about 1 to 2 cloves per day, excessive intake or combining it with certain medications, such as blood thinners, blood pressure drugs, or alcohol, can cause side effects like increased bleeding, excessive blood pressure reduction, or stomach irritation. Therefore, maintaining a balanced intake is advisable for good health. After coming out of the oven, the roasted garlic cloves are immediately transferred to the cooling area. There, an industrial fan system continuously blows cool air over the surface of the garlic, rapidly reducing its temperature. Timely cooling not only preserves the cloves' soft texture and necessary moisture, but also prevents microbial growth, thereby extending shelf life. Finally, each fragrant garlic clove undergoes thorough inspection to ensure quality and consistency before being carefully packaged and distributed to markets worldwide, ready to enhance kitchens everywhere. And that's the magical journey of each garlic clove, from the field to your table, bringing natural flavor and the power to ward off any vampires lurking in your kitchen. Imagine standing in the heart of a sun-drenched oasis, where towering date palms rise proudly toward the sky, their ripe clusters swaying gently in the breeze, carrying the sweet scent of sunlight and earth. Welcome to Egypt, the kingdom of dates, where nearly 1.9 million tons are harvested each year, accounting for almost 20% of global production and firmly holding the #1 spot in the world. Although Egypt leads in production, the United Arab Emirates takes the crown in processing and exports, while California in the US is renowned for premium varieties like Medjool, which can sell for up to 3 times the price of regular dates. But why are dates so valuable and sought after? While cane sugar, refined through an intensive industrial process, offers 99.9% pure sucrose with little nutrition, dates naturally provide up to 70% sugars, enriched with fiber, minerals, and antioxidants, outshining even raisins and prunes. Sharing the same lineage as coconut palms, date palms, whether towering varieties reaching up to 21 to 23 meters or more compact dwarf cultivars, have stood proud through over 8,000 years of history. Their resilience and enduring presence have earned them the honor of being considered one of nature's most precious treasures. Yet this majestic beauty demands a heavy price, giving rise to one of the world's most dangerous professions: climbing the swaying crowns high above to harvest dates. But before a mature date palm can yield tens of thousands of fruits each year, farmers must complete a crucial step: pollination, a process typically carried out around 3 to 5 years after the tree begins to reach maturity, depending on the variety and growing conditions. Unlike many fruit trees that can self-pollinate, date palms require cross-pollination, meaning both male and female trees are necessary for fruit to form. The process begins by identifying male trees, which can be recognized by their long, ivory-colored flower clusters. Once these flowers have matured, they are carefully cut, and the fine pollen is collected with precision. Next, skilled farmers transfer this pollen to female trees, a golden step that directly determines the yield and quality of the harvest. Typically, the pollen is applied manually to the female flowers in full bloom, either by hand or with the help of specialized spraying equipment. To give you a better idea of the scale, just one healthy male tree can produce enough pollen to fertilize up to 50 female trees. About 20 to 25 days after pollination, tiny, tender date fruits begin to form on the flower clusters of the mother tree, marking the quiet start of their journey under the sun and wind. An interesting fact you might not know is that about 2 months before harvest season, the date clusters are covered with breathable mesh bags, like natural armor, to protect them from pests and insects, while also helping the fruit ripen evenly, develop a richer color, and enhance their flavor. And if you're a patient and dedicated farmer who tends the trees until around the 6th year and beyond, you'll be rewarded with sweet, bountiful clusters of fruit each September. At small and medium-sized date farms, under the scorching desert sun, rope climbing tools become the only means for farmers to reach the towering clusters of dates high above. Once at the top, the harvester uses a specialized knife to carefully cut each bunch, then gently lowers it down using a rope system. The mesh bags previously wrapped around the date clusters, originally used to protect the fruit from birds and insects, now serve an extra purpose, catching any loose dates during the harvest. In Egypt and the Middle East, wages for date harvesting typically range from $1 to $2 per hour, depending on local economic conditions. The work requires endurance, balance, and experience, as climbing tall palms without full safety gear can be physically demanding and risky. As a result, on larger farms, the use of modern harvesting equipment is becoming a widely adopted solution, replacing manual labor with a safer, faster, and more efficient method of collecting dates, while greatly reducing the physical strain on workers. Before each operation, automated lifting machines are thoroughly inspected, and workers are equipped with full safety harnesses and specialized cutting tools like shears or harvesting knives. These hydraulic platforms can reach heights of 10 to 20 meters, allowing workers to easily access the hanging fruit clusters without the need to climb dangerous tree trunks. Once near the golden bunches, the worker gently handpicks the dates or shakes the mesh bags covering the ripe fruit, allowing them to fall safely into nets spread out below. The application of modern technology has increased harvesting productivity by up to 10 times compared to traditional manual methods, and, most notably, provides significantly improved labor safety, despite the relatively high initial investment. This core difference is a key reason why premium medjool dates from California's Coachella Valley can command prices up to 3 times higher, while over 90% of dates in Egypt and the Middle East are still harvested manually at lower production costs, making them better suited for large-scale supply chains and mass-market consumption. But the sun-drenched desert accounts for only half of the date's exceptional quality. The other half of this sweet journey truly begins once the ripe fruits enter the factory, where the final caliber of each date is ultimately determined. Upon arrival at the factory, all dates undergo an initial inspection before entering the production line. Any batches that do not meet the required standards are either rejected or diverted for separate handling. Meanwhile, the batches that meet the standards are moved onto the processing line. First, the dates are poured onto conveyor belts and transported to the cleaning area. Here, they are submerged in large water tanks with air agitation and high-pressure water jets. This step is designed to remove dirt, sand, insects, and any other impurities clinging to the fruit's outer skin. While high-pressure washing effectively removes dirt, debris, and surface residues from the dates, it does not completely eliminate pesticide residues that may have penetrated beneath the skin. Therefore, strict control of farming practices and careful sourcing of raw materials are essential to ensure safe, high-quality products. After cleaning, the dates are transferred onto multi-lane conveyor belts, which align the fruits into neat rows to prevent overlap and minimize bruising. At the end of the conveyor, the dates pass through an array of automated inspection equipment that includes industrial cameras, multispectral scanners, and sometimes gentle pressure sensors. This advanced system can handle up to 50,000 dates per hour, equivalent to the manual output of around 1,000 workers in the same time frame, greatly optimizing productivity, reducing labor costs, and ensuring high sorting accuracy. For premium whole fruit fresh products, the sorted dates undergo one final manual inspection by staff to ensure that only the highest quality fruits make it to the next stage. Depending on the intended use, the dates are either packaged fresh as whole fruits or sent to drying chambers. Drying extends their shelf life and prepares them for further processing into value-added products. For dwarf varieties of date palms such as the Barhi cultivar, the fruits often ripen to a bright golden yellow, making them especially popular for fresh consumption. These trees are easier to care for and harvest, and their fruits are also more affordable. If dried, the dates are processed using a hot air convection system where both temperature and humidity are carefully controlled. This method reduces the moisture content to an ideal level, typically below 20%, extending shelf life while preserving the fruit's natural sweetness and soft, chewy texture. Some premium products undergo additional steps after drying. These include pitting and stuffing, with popular fillings like almonds, walnuts, or soft cheeses. Once stuffed, the dates are gently reshaped using molds to ensure a consistent appearance. But the journey isn't over yet. Before we explore the remarkable uses of date seeds and the sweet, pureed flesh, we first step into the world of modern packaging. After undergoing thorough inspection, Each date is transferred into an automated portioning machine, where sensors precisely determine the required weight for each peck, ensuring consistency across all finished products. Next, the dates travel through chutes and are automatically dispensed into bags, boxes, or plastic trays, depending on the intended packaging format. A heat sealing system works in perfect sync with the portioning unit to immediately seal each package, preventing exposure to outside air and helping maintain freshness. Once the pits have been removed, the remaining fruit flesh is transferred to the grinding area to produce date paste, a smooth, spreadable product commonly used in pastries, nutrition bars, energy snacks, and baby foods. All the fruit is fed into an industrial grinder, where the dates are finely ground into a soft, uniform paste. The mixture then undergoes mild heat treatment to stabilize its structure, ensure food safety, and extend shelf life. After that, the paste is extruded through a forming machine to achieve a consistent texture that's easy to package and use. Finally, the date paste is packed into small pouches, plastic tubs, or large commercial bags, depending on its intended application. But the sweetness of dates doesn't stop there. Once the flesh is extracted, it's slowly cooked at around 80 to 90 degrees Celsius for approximately 4 to 6 hours, transforming into a rich, caramel-colored syrup that captures the very essence of the fruit. The natural sugar content in date syrup can reach up to 75%, making it a powerful and nutritious sweetener. From ancient groves to cutting-edge facilities, the story of dates is one of heritage, resilience, and innovation. Today, what began as a humble desert fruit now stands as a symbol of both tradition and technological advancement. One bite at a time. Thailand is considered the tropical paradise of jackfruit, producing nearly 400,000 tons each year. This giant fruit isn't just widely cultivated, it also brightens up the country's floating markets, where thousands are bought and sold daily from small wooden boats. But the real craze is rising across the globe. Just a decade ago, most Americans had never seen a jackfruit. Now it's becoming a new symbol of plant-based eating. Young jackfruit is especially praised as the perfect plant meat, thanks to its fibrous texture and ability to soak up flavors, turning easily into a vegan version of pulled pork or roast chicken. Many Americans still confuse jackfruit with durian because of their large, spiky appearance, but they're completely different personalities. Durian is the rock star of the tropics with a bold aroma people either love or run from, while jackfruit is gentle, sweet-smelling, and easy to share, like a friendly guest always welcome at the table. What about you? Do you prefer jackfruit or durian? The journey of jackfruit begins with tiny seeds, carefully selected from large, evenly ripened fruits. Then a gentle spray of protective solution is applied, followed by another layer of fiber to maintain stable humidity. After just 5 to 7 days, the hard shell begins to crack, revealing the first small root, a vivid sign that life has begun. From the sprouting seeds, farmers begin the planting process. They gently dig small holes, place each seed inside, and cover it with loose, airy soil. Finally, a layer of dry straw is spread on top, like a natural blanket protecting the tiny green sprouts from scorching sun and heavy rain, allowing them to safely push through and grow. As the sprouted jackfruit seeds begin to grow and push out tender green shoots, the grafting process is initiated. Farmers carefully select healthy buds from mother trees known for producing quality fruit, then skillfully attach them to the young seedlings, securing them with a thin layer of plastic film. After 7 to 10 days, once the grafted shoots emerge bright and green, the plastic wrap is removed. Successfully grafted plants are then selected and transplanted into soil, marking the start of their journey toward fruit production. With 3 to 5 years of meticulous care, including watering, fertilizing, and pest control, the mature jackfruit trees begin to yield their first fruits. Though the initial output may be modest, it signifies that the trees have adapted well and are ready to enter a stable, productive phase. As time passes, the jackfruit trees stand resilient against the sun and wind, and by the vibrant month of September, the entire orchard glows with golden hues. The plump, fragrant jackfruits peek out from beneath their leafy canopy, announcing that the harvest season has truly arrived. Recognizing a ripe jackfruit is not as straightforward as with most other fruits. When it reaches maturity, its leaves darken to a deeper green, the outer skin transitions from green to yellow. The spikes on its surface loosen slightly, and the stem begins to ooze sap. These signs typically appear in fruits weighing between 10 to 30 kilograms, the ideal size for commercial harvesting. Each jackfruit is carefully wrapped in a green mesh bag, a protective layer that shields it from insects, harsh sunlight, and physical impacts during its final growth stages. In large-scale jackfruit orchards, where hundreds of fruits can be harvested daily, workers use specialized tools with long handles and razor-sharp blades for the harvest. With a swift and precise cut, the blade navigates through dense foliage, swiftly bringing down even the enormous jackfruits hanging high above. Every cut demands absolute precision to prevent scarring the fruit's skin or breaking tender branches. Only seasoned farmers, often those with over a decade of experience, can distinguish between a fruit that has reached perfect sweetness and one that still needs more sunlight. Yet, jackfruit harvesting is far from simple. To reach fruits suspended over 3 meters high, farmers must secure themselves on sturdy ladders and carefully climb through dense branches. Once close enough, they must move cautiously across limbs, mindful not to damage young branches. When finally positioned, they make a decisive cut at the stem, slowly lowering the fruit with full concentration and strength, never allowing it to fall freely, as a single impact could bruise the flesh, scrape the skin, and reduce its value. In the canal-side orchards Klong of central Thailand, farmers have devised an ingenious harvesting method. Instead of carrying the heavy fruits manually, they cut them and let them directly into the canal. They then navigate along the water in boats to collect the floating jackfruits, maximizing efficiency by utilizing the natural waterways to swiftly transport the harvest to bustling floating markets. The freshly harvested jackfruits, bursting with vitality, are carefully loaded onto pickup trucks and motorbikes, ready for their journey to the collection point. There they undergo meticulous pre-processing, trimming leaves and stems to enhance their appearance. Once prepared, these pristine jackfruits continue their journey, traveling to bustling markets or processing factories where they are transformed into delicious dried jackfruit. Before heading into the dried jackfruit processing factory, let's first visit the bustling jackfruit market, where golden ripe fruits are stacked high, and buyers and sellers eagerly negotiate and trade. The sharp swish of knives, along with the pungent, characteristic scent of jackfruit sap, fills the air. The jackfruit cutters work deftly, hands firmly gripping thin, long-bladed knives pre-greased with cooking oil to prevent the sticky sap from adhering. With just one decisive cut, the rugged, thorny rind instantly splits open. Each golden, plump segment of jackfruit is then revealed. These are quickly deseeded, fibrous parts removed, and neatly arranged into plastic boxes or packaging trays, ready for their journey. In large markets like Chatuchak in Thailand, dubbed the fruit paradise, thousands of jackfruits are consumed daily, transformed into convenient portions for tourists and locals alike. The remaining jackfruit takes a different path. Instead of heading to bustling markets, it fulfills its purpose at modern processing plants. Immediately upon arrival at the factory, the sweet jackfruit is moved by workers into storage facilities. Here, the jackfruit is weighed and sorted according to its intended use. After being weighed, the jackfruit undergoes an initial cleaning of its exterior to remove dust accumulated during long transit. Next, the jackfruits go through the process of seed and fiber removal. Before beginning this stage, workers must strictly follow hygiene protocols to ensure food safety. They are required to sanitize their hands with a specialized disinfectant solution, typically containing at least 70% alcohol. When working with jackfruits, excessive force is not an option. Each fruit can weigh up to 30 kilograms, yet its flesh is incredibly delicate. Just a slight mishandling can bruise the segments and lower product quality. Skilled workers use razor-sharp, thin-bladed knives, sharpened daily, to precisely navigate around the fibrous core and seeds, preserving the plump texture of the fruit. Though this step seems simple, mastering it takes time. New workers typically need 1 to 2 weeks to perfect the technique of removing seeds without damaging the flesh. Experienced workers can process over 500 kilograms of jackfruit daily, working with speed and accuracy to maintain the highest standards. After the segments are separated and cleaned, the jackfruit undergoes rapid freezing at approximately 35 degrees Celsius to 40 degrees Celsius for 2 to 4 hours. This process locks in moisture and preserves the full flavor, ensuring the perfect texture for the next step: crisp, sweet dehydration. After freezing, the jackfruit is placed into a vacuum fryer, a specialized machine that operates in a low-pressure environment at only 80 to 90 degrees Celsius. Under these controlled conditions, moisture in the jackfruit evaporates gradually, preserving its natural shape, vibrant color, and original flavor. A key advantage of this method is that the oil circulates continuously during frying, but is completely removed afterward, resulting in crispy, non-greasy, perfectly intact pieces. After frying, the jackfruit is transferred to a centrifugal oil removal machine. Inside a high-speed spinning chamber rotating at 1,200 to 500 RPM, the centrifugal force pushes excess oil off the surface of the jackfruit pieces. This process ensures the final product is lightly crispy, non-greasy, and maintains an appealing golden color while extending its shelf life. After the oil is removed, the jackfruit is cooled on a conveyor belt to regulate temperature and moisture levels before packaging. Unlike traditional drying methods, vacuum frying delivers superior quality, producing jackfruit that is crunchier, more visually appealing, and richer in taste. Despite the distinction in processing, many people still refer to it as dried jackfruit, rather than the more accurate term, vacuum-fried jackfruit, simply out of habit. Once fully cooled, the jackfruit moves on to the quality inspection stage. Here, workers meticulously examine each segment by eye, discarding any pieces that are burnt, broken, discolored, or fail to meet the required size standards. The selected jackfruit segments are transferred to the packaging area. Each crispy piece is carefully sealed in specialized airtight bags made from moisture-resistant materials, effectively preventing humidity from seeping in. This protective layer ensures that the jackfruit retains its signature crunch, avoiding softness or texture degradation even during long-term storage. Each bag typically weighs between 100 to 200 grams, making it both convenient for consumption and optimal for preservation. One crucial but often overlooked step is the gas flushing system, where an inert gas, usually nitrogen, is pumped into the bag before sealing. Nitrogen creates a stable environment, preventing oxidation, preserving the jackfruit's vibrant golden color, and extending its shelf life without the need for artificial preservatives. Thanks to this meticulous packaging process, vacuum-fried jackfruit can maintain its crisp texture and distinctive flavor for 6 to 12 months. Colombia is hailed as the tropical capital of soursop, supplying around 10,000 tons each year, nearly 10% of the world's total production. But its allure extends far beyond lush green orchards. It has crossed borders, reaching as far as the United States. From a virtually unknown name, soursop has now become a tropical jewel, sought after in the land of the free. With its dark green skin covered in scattered spiky bumps, the soursop's appearance might evoke the image of a prickly warrior, ready to draw blood. Yet upon touch, those spikes reveal themselves to be soft and pliable, just enough to deter small insect pests, while posing no harm to the hands of pickers or to larger animals, the seed couriers that help the tree spread its life. Compared to durian or jackfruit, soursop is the multitasking master of tropical fruits, capable of transforming into juice, jam, ice cream, tea, or even inventive savory dishes. Every 100 grams packs about 20 milligrams of vitamin C, over 3 times that of jackfruit, along with abundant fiber and potassium. Delicious yet highly nutritious, it has managed to conquer even the most demanding markets. And to produce soursop fruits of such quality, everything begins at the planting stage, the foundational step that determines the vitality and growth potential of the young trees. The ideal soil is sandy loam, loose, rich in organic matter, able to retain moisture while draining quickly. After breaking up and softening each handful of soil, the grower gently places it into seedling pots. This layer of soil acts like a warm cradle, nurturing the seeds and helping the sprouts break through their shells to reach for the sunlight. Thorough soil preparation is only the opening act. Sowing the seeds is the decisive moment. Soursop seeds are laid horizontally, about 2 to 3 centimeters deep in moist soil, then lightly covered with loose earth, never compacted, so that the young roots can break through with ease. Moisture must be kept consistent, as even a single instance of overwatering can cause the seeds to rot or the tender sprouts to suffocate, losing their chance to grow, slowing their development, or even failing to germinate altogether. When the young sprouts emerge, the green shoots quickly reach upward, with tender leaves unfolding to signal the plant's growth phase. Growers closely observe and select seedlings that meet the standard height of 10 to 15 centimeters, with sturdy stems, even leaves, and roots firmly anchored in the substrate before proceeding with transplanting. Each seedling is lifted from the nursery tray with a firm yet gentle motion to avoid damaging the roots. In the new pot, the soil is mixed to be loose, nutrient-rich, and well-draining. The seedling is placed upright, with soil filled to the collar of the roots to prevent waterlogging and keep the stems stable. Moisture is maintained at an optimal level to encourage rapid root expansion and help the plant adapt quickly. From here, the soursop continues to be cared for and monitored for pests and diseases until it is strong enough to be planted in the field or delivered to commercial nurseries. After selecting healthy seedlings, growers place the root ball into the planting hole, keeping the root collar level with the soil surface to prevent waterlogging. Soil is filled in and gently pressed around the base, providing stability without damaging the roots. One fascinating trait of the soursop is its picky flowers, each bearing both stamens and pistils, but never maturing at the same time. In the morning, the flower is in its female phase, ready to receive pollen. By afternoon or the next day, it shifts to the male phase, releasing pollen but no longer able to receive it. This is why farmers practice hand pollination. In the afternoon, they collect pollen from male phase flowers, store it overnight, and the next morning use a soft brush to transfer it to female phase flowers. This perfectly timed appointment results in a remarkably high fruit set, producing large, uniform, and visually appealing soursops. From the moment it is planted, a soursop tree typically takes about 3 to 4 years to bear its first crop. Over time, the trees push through rain and sun with resilience, and by late summer, the orchard is cloaked in a lush green hue, signaling that harvest season is truly knocking at the door. Identifying a ripe soursop is far from as simple as with many other fruits. At peak maturity, its dark green skin begins to pale, the spikes soften, and the stem reveals delicate, hairline cracks. These traits are often found in fruits weighing between 1.5 to 3 kilograms, the ideal size for premium quality. Harvesting soursop requires a gentle touch, as the fruit is soft and easily bruised. Pickers typically use sharp pruning shears or specialized knives to cut the stem, rather than pulling by hand, to avoid damaging the flesh or stem base. Each fruit is held firmly in the palm and placed gently into a padded basket to minimize impact. In orchards along the canals, instead of carrying heavy loads, farmers skillfully cut each fruit and drop it softly into a boat waiting below, then simply paddle along the rows of trees to collect their bounty. Few people know that soursop has a close relative, the custard apple. Unlike the elongated shape, soft and sparse spiky skin, and slightly tangy flesh of soursop, the custard apple is rounder, with a rind made up of distinct, closely packed segments resembling dragon scales. When ripe, the custard apple's skin cracks slightly, revealing its rich, sweet white flesh. Harvesting custard apples is also different. The fruits are smaller and firmer, so pickers only need to gently twist the stem without worrying about bruising, unlike soursop. This difference not only creates two distinct flavors, but also changes how farmers harvest and store them. Many people often confuse these two fruits because of their similar appearance and names, but in reality, they have clearly distinct characteristics and values. Whether it's soursop or custard apple, once freshly picked, each plump fruit is immediately taken to the collection point in the orchard. There, buyers carefully sort the fruits. Those meeting standards for size, ripeness, and appearance are separated. Beautiful, intact fruits without bruises or pests are reserved for fresh consumption in supermarkets or exported to foreign markets at a higher value. In countries like the United States, or across Europe, imported soursop can fetch prices ranging from 2 to 5 USD or more per fruit, due to transportation costs and scarcity. On the other hand, fruits that are overripe, scratched, or show signs of pests are removed from the fresh produce line. However, not all imperfect fruits are discarded. These are usually sent to processing plants to be made into soursop juice. In processing, imperfections in appearance no longer affect the final product's quality, allowing maximum use of raw materials, reducing waste, and increasing economic efficiency. As soon as the baskets of fresh soursop arrive at the processing facility, the fruits are passed through a high-pressure spray washing system that effectively removes dirt and impurities from the spiky skin, preparing them for the subsequent processing stages. Immediately after washing and sorting, the selected soursop fruits proceed to the peeling stage. Although the spiky skin of soursop is not thick, it has a soft structure with numerous prominent spikes, while the inside consists of juicy white flesh that is extremely delicate and prone to bruising. Using high-speed mechanical peelers can easily tear the flesh due to friction and pressure, causing juice loss and significantly diminishing the fruit's flavor. For this reason, many factories still prefer manual peeling, performed at a moderate speed with hand pressure carefully adjusted for each individual fruit. Each worker is trained to glide the knife closely along the skin, removing the spikes and outer green layer without damaging the tender flesh inside. A lesser-known fact is that the peeling room's temperature is strictly controlled. If too warm, enzymes in the fruit become overactive, leading to discoloration. If too cold, knives struggle to glide smoothly over the surface. Immediately after peeling, the soursop pulp is fed into a hydraulic press, extracting a thick, fragrant juice that preserves the fresh flavor and rich nutrients intact. In the packaging process, soursop can be packed using various methods, the most common being bagging and canning. With bagging, fresh soursop fruits are carefully wrapped in mesh or plastic bags to reduce impact and maintain freshness during transport. On the other hand, with canning, processed soursop is fed into a modern canning line. On gleaming steel conveyors, chilled cans of soursop juice roll steadily forward, passing through high-speed filling and sealing systems. In the blink of an eye, each can is perfectly sealed using aseptic technology, preserving the fresh, natural flavor inside and preparing it for long-distance shipping. Each method has its own advantages and is chosen depending on the intended use and target market. And while ripe soursop delivers a gentle sweetness with a hint of tartness to create a refreshing glass of juice, unripe soursop begins an entirely different journey, the journey of becoming soursop tea. After being thoroughly washed, the unripe soursop fruits are fed into a specialized slicing machine, cutting them into thin slices of only about 2 to 3 millimeters. The seeds are kept intact during the process, as they contribute to the light astringency and distinctive aroma of soursop tea. These thin slices allow for even drying, preserving the golden color and the fresh, natural flavor to perfection. The thin soursop slices are then placed into a drying chamber at a temperature of around 60 to 70 degrees Celsius. Under circulating hot air, the moisture inside gradually evaporates, leaving behind crisp, deep golden flesh, infused with its signature aroma. At this stage, each slice has transformed into soursop tea ingredients, ready to bring a gentle astringency, delicate freshness, and a lingering, sweet aftertaste to the drinker's cup. Once the soursop reaches the desired level of dryness, it is transferred to the roasting stage at a moderate temperature. This process enhances the aroma, stabilizes the color, and preserves all of its natural active compounds. After the roasting process is complete, the dried soursop is transferred to a sealed packaging area. Here, each batch of tea is precisely weighed and packed into specialized bags or boxes, then vacuum sealed to preserve its full aroma and crisp texture. Every finished product is a bundle of fragrance, ready to be delivered to tea lovers. Imagine yourself standing in an endless almond orchard, where rows of sturdy trees stretch under a clear blue sky. Welcome to California, the kingdom of almonds. Every year, California produces over 1.2 million tons of almonds, accounting for 80% of the world's supply. Behind the humble exterior of the almond lies a massive industry worth billions of dollars. Few people know that just over 20 almonds contain up to 160 calories, equivalent to a chicken drumstick. Despite the high calories, almonds are a miracle for dieters thanks to healthy fats that keep you full longer. However, eating too many can backfire. Eating less but right is the smart choice. But almonds are more than just nutritional value. Beneath the pure white beauty of almond blossoms, producing 1 ton of almonds requires over 10 million liters of water, while California is suffering from severe drought. Therefore, as sustainable production gains attention, each harvest marks a new beginning, where cultivation efforts, technology, and faith in a greener future come together in every ripe almond. The journey of almonds begins in January or February, when young almond trees are planted in California's Central Valley, the almond capital of the world. With its hot, dry climate and fertile soil, the region offers ideal conditions for these trees to thrive year-round. At first, the trees are planted in evenly spaced rows and paired with drip or micro-sprinkler irrigation systems, which deliver water and nutrients with precision and efficiency. Modern drip irrigation systems allow water to go directly to the roots, minimizing evaporation and waste. Meanwhile, micro-sprinklers help maintain even soil moisture and deliver fertilizers through the water, supporting healthy growth throughout the tree's life cycle. What sets almonds apart from many other crops is their deep root system and high water demand. This is largely because their growing season coincides with California's dry months, requiring consistent watering to maintain tree health and productivity. Although drip irrigation helps conserve water, the fact that almonds bear fruit annually means water consumption remains high to sustain yields throughout the production cycle. In the first 1 to 2 years, farmers focus on developing strong canopies and healthy root systems. Modern machinery is used to prune dead or overlapping branches, ensuring each tree receives ample sunlight and grows vigorously. By the 3rd or 4th year, when the trees bloom in vibrant shades of pink and white, the pollination season officially begins. At this time, over 2 million beehives are brought into almond orchards. The bees gently collect pollen from the newly blossoming flowers. With their busy wings, they transfer pollen from one blossom to another, promoting fruit development in the almond trees. For years, almond growers have partnered closely with beekeepers to ensure successful harvests, a collaboration that supports healthy trees and high yields for seasons to come. After months of care under the summer sun, by late summer to early fall, the green outer hull of the almond begins to split open, like a smile from nature, signaling that harvest time has arrived. To harvest almonds quickly, a machine called a tree shaker is used. The tree shaker is an agricultural engineering marvel, equipped with a mechanical arm and hydraulic drive system that clamps securely onto the tree trunk. When activated, it produces rapid and precise vibrations, almost like dancing with the tree, creating a joyful rain of almonds that fall evenly and efficiently. Each tree shaker can harvest 10 to 15 almond trees per hour, depending on its size and capacity. In the past, farmers had to shake trees manually using long poles, which was time-consuming and posed safety risks. The advent of the tree shaker has drastically shortened the harvest period from several weeks to just a few days, reducing labor costs and nut loss while boosting overall production efficiency. After the almond rain from the tree shaker falls to the ground, a modern device called a sweeper is used to make the harvesting process easier. The sweeper is equipped with rotating brushes that gently sweep the almonds into long, straight rows, known as windrows. These rows are neatly arranged between the tree lines, creating tidy strips of nuts, ready for collection. The machine operates smoothly, allowing for quick gathering while minimizing damage to leaves and soil. Organizing the almonds into windrows helps the harvesting equipment work more efficiently, speeds up the collection process, and protects nut quality by reducing breakage. After a few days of sun drying to reduce moisture and improve nut quality, the main harvesting phase begins. Almond sweepers move along the windrows, collecting the nuts and transferring them into specialized trucks. These machines are often equipped with advanced fans and filtering systems that help remove leaves, twigs, and dust, ensuring that only clean, intact almonds are gathered. As a result, post-harvest processes like sorting and processing become easier and more efficient. Finally, the harvester began pushing rows of almonds onto the long conveyor belt. The nuts poured into the truck bed like a small stream, layer upon layer, dusted with soil and kissed by the sun and wind, painting a vivid picture of the harvest season. In just a moment, the truck bed was piled high with mountains of almonds, ready to set off, carrying with them the breath of the earth and the hopes of the farmers for a bountiful season, beginning a new journey from orchard to table. When almonds are transported to processing facilities, they often still have their green outer hulls and hard shells, along with some debris such as dry leaves, small twigs, and soil. Before hulling begins, the almonds undergo a thorough cleaning process. First, they pass through a de-sticker machine, which removes larger branches without damaging the nuts. Next, the almonds move to the destoner, where a stream of air blows away lighter debris, while vibrations help dislodge any hardened soil clinging to the surface of the nuts. Finally, the almonds pass through a de-twigger, which completely removes any remaining small twigs and impurities. The next step is hulling. The process begins by loosening the green outer hull using a gentle rotating or friction mechanism. The loosened hulls are then removed by a vacuum or air suction system, ensuring the production line remains free of impurities. After the outer hull is removed, the almonds are transferred to a gravity table to separate any remaining debris. Nuts that still have their hard shells continue along the main processing line, where they pass through a camera-based inspection system that detects and removes any substandard almonds in preparation for the next shelling stage. The shelling process begins by feeding the almonds, still encased in their hard shells, into a specialized shelling machine. This machine uses gentle mechanical force to crack and separate the shells, while ensuring the almond kernels inside remain intact and undamaged. After shelling, the almonds are transferred onto a vibrating conveyor equipped with sorting holes to classify them by size. Smaller kernels fall into separate bins and are typically used for almond butter or baking ingredients. Larger kernels continue down the line to meet the standards of premium markets. It is common for the upper class to leverage their financial and social power to pay a significant premium for the privilege of securing the highest quality almonds during the very process in which they are being sorted. In a high-tech environment, almonds undergo quality inspection using advanced computer software. Supercomputers operate around the clock to identify almonds that meet strict quality standards. Next, high-resolution scanning cameras detect tiny cracks or surface scratches on each almond. The system then calculates the exact coordinates and sends the data to robotic arms. These robotic arms swiftly and precisely remove the defective almonds from the processing line. Finally, human workers perform a final inspection, removing any remaining defective almonds to ensure the highest quality. The almonds are then sorted into bins of different colors based on their quality. Red bins typically hold premium-grade almonds, while green and yellow bins contain second-grade ones. This manual sorting process helps detect subtle imperfections and handle special cases, tasks that automated systems may not execute perfectly. Steam pasteurization is the most common method used in the United States, in which hot steam is applied for a short duration to eliminate harmful bacteria such as salmonella. This process is highly effective, preserving the natural flavor and texture of the almonds while meeting strict food safety standards. After pasteurization, the almonds are moved to the packaging stage. Large bins are carefully prepared and securely sealed to preserve freshness and quality during transport. These bins are then delivered to specialized processing facilities. There, the almonds continue their journey, being transformed into delicious products such as salted roasted almonds or sweet almond toffee. To make salted roasted almonds, the nuts are placed in an oven or automatic roaster and roasted at a temperature of 150 to 180 degrees for about 10 to 15 minutes to ensure they are evenly cooked and crispy. While still hot, the almonds are sprayed with or coated in a salt solution for even seasoning. Finally, the nuts are quickly cooled and sealed in airtight packaging, ready to be delivered to customers. Alongside salted roasted almonds, another irresistibly sweet treat is almond toffee. a crunchy, buttery snack that delights with every bite. The main ingredients for toffee include sugar, butter, cream, and a pinch of salt. First, the butter and sugar are melted together in a large pan over medium heat, stirring constantly to prevent burning and to create a smooth mixture. Next, heavy cream is added to enhance the texture and balance the sweetness. The mixture is then cooked to a high temperature, around 150 to 155 degrees Celsius, 300 to 311, until it reaches a soft, pliable consistency. Once the desired consistency is reached, the butter-sugar mixture is poured onto a metal surface to cool before moving on to the next stage. As the mixture cools and solidifies, it is cut into small pieces. Sharp cutting blades are typically used for this process, ensuring precise cuts so that each toffee piece is uniform in size and shape. Next, the toffee pieces are transported along a conveyor belt, where a stream of warm chocolate coats the surface evenly. This chocolate layer creates a smooth outer shell and enhances the toffee's distinctive flavor. And finally, the most important stage arrives, just as each chocolate-coated toffee piece sets into a glossy, rich finish. They are then bathed in a golden shower of roasted almond slivers. The fragrant, oil-kissed almond shards cling tightly to the still warm chocolate, forming a crisp, flavorful armor. It is this delicate harmony between the nutty, mellow almonds and the rich sweetness of the toffee that gives the candy its soul and iconic character. And so, the journey of each almond comes to a close, from sun-drenched orchards, through modern technology, to fragrant roasting ovens. Each tiny almond now wears a unique coat, ready to awaken the senses and carry the story of a land's unwavering dedication.